Hi, and welcome to the Automation Village Virtual Trade Show. I'm your host, Dave Spencer. Over the next 3 hours, we'll have approximately a dozen presentations, all related to the Scada and automation industry. While currently it's more difficult than ever to connect with one another, we realize that many of our customers and users in critical infrastructure are unaffected by the recent social distancing, and therefore we must support them sort of equivalent to what they were getting beforehand. Now this means making some changes to the way we do our workflows and to become more efficient in the current environment. So to paraphrase Gene Kranz, I would say, failure is not an option, keep working the problem. Personally, I'm looking forward to looking back at this time to find out what new norms we find we have to carry onward from the problems that we're solving today. I'm also hearing stories from my engineering team about working on site via telepresence, and I'm very curious to follow up with them to see how that had worked for them and to see what things they would need to do a better job today. If you see me looking down during the presentation, it's because I'm running several different things here, and so give me a moment to queue up. Next up, I think what we'll do is head to co-host Chris Little, because Chris and I had a little bit of an interesting experience as we were trying to get ready for the show, keeping our social distancing, and that's probably a good time to segue over to bring Chris on. Hey Chris, have I got you here?
Dave and I normally are just 2 doors down from one another at our headquarters in Bedford, but today we are appropriately isolated. And so how are you feeling, Dave? We've had quite a morning.
Yeah, it's been very busy, certainly. I'm feeling pretty well now. I think once we get rolling with the stream, the nerves will fall and everything will happen. But as always, the seconds before the show is when all of the drama occurs, right?
Yeah, that's right. So if only you could have watched what just occurred over the last half hour. And so thanks, everybody, if you got to watch a few seconds of things bouncing back and forth. As Dave mentioned, we've combined a number of different technologies, many of which would be familiar to all of you right now, such as GoToMeeting, and also an interesting camera setup called Sling Studio, and a few other things.
Right.
So, of course, we've combined them all together, and the good news is that either you're going to get an interesting, innovative 3 hours of Scada content, or you're going to watch a building on fire. So either way, I think it's going to be really entertaining.
Yeah, that's you've seen us do the high diving act before, and I was thinking about the correct metaphor for this, and I think this is the synchronized high diving while blindfolded act. So we've got Chris and I in different locations, and also in my ear here I've got Pete Diffley, who's our producer for this event, who is speaking to me from his office in Charlotte, North Carolina. So we've got people scattered sort of globally because we can't be together. So
these are, I don't have a lot of time to go through each of these, but this is roughly in no particular order who we'll be listening to and watching over the next 3 hours. Great, so now we need to talk about our competition rules. We have competitions, so at various points through the 3 hours, we are going to give away $100 online shopping vouchers for a very popular online shopping thing. And what's going to happen is later on, we're going to show a slide. We're going to have a code and an email address. So when you see the slide, and we'll tell you again and again and again, type this code into the subject line of email and send it to Natasha Lutz. And we will be giving away a number of these through the day.
all right, thanks very much, Chris. Next up, we're going to have Glenn Wadden come in. Just don't mind me while I change the audio sources and stuff. So Glenn Wadden's going to talk about changing times. So I'm just queuing up here to bring Glenn on. And bringing Glenn in now.
Good morning, everyone.
Hey, Glenn, how are you?
So,
Morning, Glenn.
I'm doing great. So it's exciting times in some ways, but also change is going to produce opportunities. So we've got to look at these changing times and see how we learn to do better. So, say welcome everybody to the first automation trade show. We are kind of excited that we can get this going. We saw that over the last 10 days or so, we just got into from a concept to delivery. So just as Dave warned you, expect to see a few little bumps along the way, but our hearts are in it, and we're hoping to make this a success for everyone involved. I want to give you a little bit of sort of a background of the company here and my involvement. 3 weeks ago, we were in Florida. We did our VTScada Fest, our annual users group show, and that was a huge success, a sellout. It was kind of a little bit intimidating for me. I'm not a front man kind of guy generally, but being up on stage, the lights shining in my eyes, I couldn't see the audience out there. And it was a really exciting time, but I'm feeling a little bit of deja vu now. I can't see the audience out there, and I don't even know if anybody can really hear me. So one of the things I noticed back at VTScada Fest was that I was walking through the halls of the hotel, and I heard someone on their cell phone saying, I'll send you a change set. And I thought, wow, that's really something. They're talking about VTScada. Just someone sort of, not quite random, but someone in the hallway talking about our stuff. And I remember watching a week before that, a show on one of the documentary channels that I like to watch called Big Fixes. They're showing a repair of a turbine shaft at Niagara Falls generating station. And they panned through the control room, and there on the screen was VTScada. So we seem to be soaring to new highs, at least highs for me, that I can see that the product is really taking hold. So I'll give you a little bit of background on the origin of the company. I've always been fascinated by a little bit of magic in the world. And by magic, I mean things that are hard to understand, they're complicated, but there is some intrinsic details there that you can use the science or math involved to solve problems. I started out being very intrigued by math in high school. I went into physics because I could see strange forces like magnetism and gravity making things happen. You could solve problems, and moved on to electrical engineering because you could even solve more problems. And then ultimately got into digital electronics and then into software, because software systems are really the most complicated systems that humans create. Now, software, if you take a look at people saying that computers are make the world go round, and you can see some of that today for sure. But it's really software running on computers that's making the world go. If you look at all of the computers that are making today possible, it's just astounding if you start to count them up. And all the software that's running on all those computers. We're involved in an industry that's really making modern life possible. Where the company started, I worked for a small company in Nova Scotia that made pump controllers for lift stations, and they wanted to do a telemetry system. This was back in 1983. And they hired me out of the university, and I worked on a project to write software for an IBM PC. That worked out quite well. We got some old-fashioned modems, wired them up to some taxi cab radios, to an Allen Bradley micro PLC, which had a whopping maybe upgraded it to 512 bytes, not kilobytes or megabytes or gigabytes, but bytes. This is small times, but it actually worked. We did this for several of the cities, writing the software from scratch every time. We decided that what we really needed was a tool to make this possible going forward, because writing the software every time created bugs, difficulty in maintenance. It required reliance on single people. It wasn't going to scale very well at all. So the company I worked for didn't really want to invest in that. I spun off and started with Trihedral. I started by myself in a spare bedroom in my house. And 33 years later, I'm talking to you out of a spare bedroom in my house, where there was an office in between there for many, many years. But the current situation has kind of brought us full circle. Looking at the philosophy of business, we started this company 2.5 years after I started, I brought on a partner who was Ralph Spencer, had the same kind of view of the world that I did. He was a guy that I worked with coming out of university at the first company. He used to tell me that we want to make the customers say, wow, we want to really do a good job for them. We want to go over their expectations. Now, this is what we're up to. We want to do it best. And that rang true with me, and it has rung true with all of our employees. It's our motivation. It's not about making money first. It's about doing the job right. And we want to make the world a better place by creating the best SCADA software platform. Now, what motivates us is just to make you say, wow, we want the world to run better. We want to do a quality job. We want to serve our customers well. One of the things we always tell our staff, when we have our annual general meeting, we have an annual meeting in April every year where we bring all our staff together, show them all our financial statements. We open up everything we're doing, all our plans. And one of the things I always tell them is a customer with a problem is our number one issue. Everything else aside, don't worry about the big project that might be coming up that we're bidding. It's the one that we have now that has a problem is our number one focus. We always think that fairness applies to everybody that we deal with. We deal fairness with our employees, fairness when it comes to dealing with suppliers, and especially with customers. So it's an attitude we have. We really want to create the best software and do it in a way that delivers value to the world. We're not just trying to make it better to get ahead of the competition. I mean, we're aware of the competition, and if they have good ideas, we'll learn from those. But our goal here is to make it better regardless if there's competition or not. We're out there to solve problems. We're always focusing on the problems of the world and not just...
In the last 2 minutes, why don't you discuss how VTScada, what that can contribute in moments of crisis?
Right, I'm glad you brought that up. This is where I'm going to segue to anyway, Chris. So there's half a dozen features here that I think are really important in this kind of time. So the Anywhere clients, first and foremost, we've got this ability to look at the system remotely through a tablet, your phone, your laptop computer, or your home computer. We've got version control. What that allows people to do is to take the changes that they would otherwise have to bring in a system integrator to do simple changes. They make them themselves. They can do them with confidence because if they don't work, they can always roll back and go back to where they were. Our change set's a great tool for working remotely. If you have an isolated system where remote access is not possible, change sets are easy to email back and forth and allow people to remotely configure the system without having to get physically there. We have the Idea Studio on the VIC on version 12 now. That allows people just with remote access on a Windows desktop, without installing a full client, to configure the graphics on a system. And that's a new in version 12, where a lot of people are really kind of excited about that. Long-standing feature, the alarm notification system. Great system. It allowed a lot of operators early on in their adoption of VTScada to run on man, because you can actually leave the system unattended and it will notify it by a number of different means that there's a problem.
Glenn, forgive me, the taskmaster in my ear is telling me that we have 5, 4, 3, 2. Thanks, Glenn. And over to you, Dave.
Thanks, guys. I appreciate that. Next up, we hear a lot of talk recently about security. I think that's probably one of the number one topics that kind of comes in and out. And it seems like security is one of those things that isn't necessarily discrete in nature. There's a lot of give and take in different security practices. And so it's great having different experts available that we can use to talk to. So, leading up next, we're going to have Scott Coleman of Owl Cyber Defense Solutions, and Scott's going to speak to us a little bit about best practices for cybersecurity and a little bit about protecting your systems. So let's just jump over to Scott there.
Great. That was a much better introduction. Thank you. Hi, Scott. How are you today?
Very good, thanks. Appreciate being invited to participate.
Oh, I'm glad you could do it. So tell us, so this is one of the ways, this virtual trade show is one of the ways that we are trying to adapt to a different world. Tell us a little bit about how OWL Cyber Defense, what kind of tools and strategies that you're finding successful in the last couple of weeks.
Sure. So part of, unfortunately, you can actually look at this situation we're currently in and apply it to what's happening in cybersecurity in terms of best practices. The whole concept of physical separation and segmentation and moving people away from threat areas and keeping them out of threat areas is really what we're doing in terms of cybersecurity and what we've been doing for 20 years. So we've all gone remote at our company, and we're using remote tools and remote access, etc. And that's a lot about how actual plant operators, etc., are using our products and out in the field today.
Okay, that's great. So what are we going to talk about today?
Yeah, so I think that the fundamental thing we want to get across is really talking about remote access, remote monitoring without remote access. Glenn was just talking about like emailing chain sets and alarms and notifications. Those are all examples of things that can go through what's called the data diode. 20 years ago, we started the company serving the US government. We get the first patent in what's called the data diode. And I'll explain that in a second. And since then, we've actually added about 50 new patents onto that. And about 10 years ago, we took that technology and brought it over to basically the industrial control systems or critical infrastructure part of the marketplace. A data diode, for those that aren't familiar, is a pure cybersecurity device. It is based on hardware, not software, so it's not something that can be configured. We actually let people know that it can't be hacked. Which sounds a little audacious, but I'll explain in a second why we say that. And it's comprised of the core elements really are the LED that's sending light across the diode from the source to the destination, and the photo receiver on the receiving side that's receiving that data. That's
interesting. It never occurred to me that this actually included an actual diode.
Yeah.
I just assumed that was a metaphor. The things can only happen.
Yeah, it's funny because there were trade shows, and I know when the guys that get the electrical engineering degrees come up to me because okay, I know what a diode is. So a data diode moves data in one direction. And I'm like, yes, you got it exactly right.
Also, there's a diode.
Yep, absolutely. In theory, there's actually two because there's the send side and the receive side. So you've actually the diode acts as the demarcation point between your plant, let's say, and your HQ where you're going to accumulate information. So maybe in Glenn's example, where the alarm notifications get sent to is one side, and where the sourcing are coming from is the other. So this next slide is really talking about the number of connections you have, because you think about, well, where do diodes get used? And you got to step back a little bit and think about, well, what are those connections and how many of those connections exist? And the average facility has 583 connections. There's a lot of connections that you need to apply cybersecurity resources to, and everyone knows we've got limited resources today. So not to say that a bunch of those 583 aren't valid. We all have reasons why we want to connect our operations to other entities. Whether it's to the cloud services, software vendors, disaster recovery solutions, etc. There's a long list there of different reasons and why we need to have external connections and connectivity to our network. And then you have different data types. You have historian connections, obviously Scada connections, we're talking about today, SIM information, files, syslog, email, etc. All kinds of different data types that need to get from that plant out to end users. And this is kind of what it looks like, right? You've got your plant, your facility in the middle, and you've got all those third parties sort of sitting out there around that plant trying to exchange information back and forth. And what we want to try and do is control those connections. And so the Department of Homeland Security actually came up with what they refer to as their 7 strategies for defending industrial control systems. And if you break it down, the way to think about it is that 583, you want to reduce that number, right? So you want to get as few as possible so you can then concentrate your cybersecurity resources. And then the next recommendations they make is about converting two-way connections, because we saw those are the two-way arrows between all those entities, and we're going to connect them to one way out of the plant. And that's really where diode comes in. So the idea with the data diode is, I know because of the physics that you mentioned, the physics is what is the security. The bedrock or the core of the security there is moving data in one direction only. If I don't have components that can move light backwards, then I can't hack the box. And that's really what we talk about being unhackable. Is that idea of I can only move light one direction, no one can hack through a diode and get back into the plant. And it's all about protecting the plant, your SCADA, your storing systems, all the things running on the inside of that plant that are needed and critical for operations.
Right, so in order to hack it, you need some kind of feedback from the unit. I'm putting something in, I want to see what I get out. And if you can't do that, then you can't hack it.
Exactly, right. There's no remote command and control. There's no two-way communications back and forth through a diode. And that's the intent. The intent is, hey, I can only move information in one way. Therefore, there's no zero-day exploit that you can put on there. You've actually got missing components, right? There's no way to physically go back. So there's no software you could load on there that magically will recreate the missing pieces of hardware that are required to go backwards through a diode. You put in a diode, you can be 100% guaranteed that there's no way you can anybody can get back through the diode into the plant, but you're guaranteed you can get your data out. Yep, that's exactly the point. So some of the people talk about, firewalls where they run on hardware and stuff, but they're not based on hardware, right? They're not based on physics. Software firewalls are based on configuration enforcement, and zero-day exploits, as we know, can still impede them and affect them. You can have people configure things incorrectly, malware, ransomware, all those things can be propagated and work their way through a firewall. And you've got ongoing management where you've got to constantly keep them updated, otherwise they're no longer going to serve the need that the end user is expecting out of them. So with a hardware enforced data diode, and you get the physics, it becomes unhackable, it's invulnerable to your malwares and other things, and there's very little ongoing management.
Great.
Some people say, okay, great. So some people say, well, that's interesting. The data diode that must be used sort of like in this one thing where you're just moving a file or something. But the truth is, it's big use all of it. We've got a lot of deployments in water, wastewater, power generation, nuclear power plants, renewables, wind and solar. A lot of things going on in transmission distribution. We've been very strong in oil and gas for that was actually our first foray into critical infrastructure was actually the nuclear plants. As many folks know, that those are all very locked down, one way only. And then from there, actually, there were some threats that occurred in the Middle East. And so we started oil and gas, got into that space subsequently. And then all these other markets, petrochemical, transportation, et cetera, have all started to adopt data diodes. So we're really seeing a lot of activity now. I guess one way you can tell that there's an interest in the market is when you start to see a lot of competitors pop up. And so we started to see a lot of smaller entities creating diodes. And I think that the baseline there is anybody can create for that one-way data diode. It's really about the expertise in being able to connect to the networks on either side. So the diodes is in the middle, that's great. But when you come to the point where you say, you know what, I need to get OPC UA data out. I need to get Modbus data across. I need to do emails. I need to do files. I need to do streaming. I need to replicate historians, all those kinds of things. When it comes down to those things, it's really being able to manage those data types, connect to the networks on either side and get the data in, across, and back out the other side securely and reliably without impeding any of the plant operations.
Okay, just in the last 30 seconds, who's looking for this solution? What end user for this?
Sure. So we actually have 4 personas we target. The OT engineer working in the plant, the IT engineer who needs to get that monitoring information, and then we have partners that we work with like yourselves, and then of course CISO. So it's a variety of folks that are interested in technology, doing proof of concepts, and really exercising the solution.
That's great. Thanks, Scott. That you really covered a lot of territory in a short time. We really appreciate it. Have a great day.
Thanks, you too.
Over to you, Dave.
Thanks, Chris. Thanks, Scott. That was really interesting. I think, like a lot of other people, I've heard a lot of information about data diodes. I hear the term used a lot, but I've never really had that kind of more detailed look at what and why the data diode really is there. I like the idea of having actually one in each direction. I didn't know that it worked like that. So next up, we're going to have Devrej Sen, Devrej is the R&D manager at Trihedral, and Devrej is going to talk a little bit about his experience.
My journey at Trihedral began almost 20 years ago, while I was attending university in Canada. I applied for a co-op position to gain more experience as a software developer, and it was not an easy task. I remember being put through a very challenging interview, but years later, I have grown with Trihedral, and today I manage the software development team. Our Trihedral family is made up of a bunch of friendly engineers, developers, and salespeople who are extremely accessible to one another. In fact, our engineers are our primary user of VTScada, as they take real-world projects from start to finish and provide the developers with invaluable feedback. This gives us a unique perspective. It allows us to consider new and better ways, and if we see that they are correct, we are not afraid to lead with that. Ironically, some of the most challenging problems that we have solved while developing VTScada are not easily apparent on the surface. Take synchronization for an example. VTScada's synchronization is an evolutionary approach to SCADA redundancy, and although it is a very complicated implementation under the hood, it comes across as effortless and seamless and intuitive to the user. That has always been the goal, because we put a great deal of effort into removing any complexity from the user, and then we follow it up with rigorous testing. The result is a robust industrial solution, which is not only simple and efficient, but flexible and feature-rich. Another thing we excel at is support. I challenge you to find a company which provides better support than us. It gives us a great deal of satisfaction when a customer who has endured a significant event like a hurricane credits VTScada with protecting their data and giving them the ability to respond confidently in the aftermath. Trihedral set out to create the best SCADA software possible. And these are just some of the few examples of how we have redefined the expectations of an entire software category. I am proud to work at Trihedral creating VTScada.
Next up is Dave and Chris speaking to what's going on in the next 30 minutes. So next up, we're going to do the use of drone technology with Mervyn Betts of BetSem Controls. And after that, there'll be a little bit on SCADA configuration version control with Blair Suley, who's another member of the VTScada team. Chris, we talked a little bit about BetSem and drones, and we went through this yesterday with Mervyn, and I thought it was really interesting. He had a whole lot of different things to add to the conversation, which I thought were really quite unique. Yeah,
this is not what I was expecting when he first sent us this video, which we're going to watch in a little bit. This was not exactly the implementation of drones that I was expecting in a SCADA environment. That this solves this very specific problem that's actually about video file size management, or video or volume of video management, which is really interesting. So in a moment, we're going to bring Mervyn on. Are we ready to bring him on now?
I'm here.
Okay, great. Okay, so Mervyn, thanks for joining us. Sorry, I'm just listening to voices in both my ears. Thanks for joining us. Glad we can hear you. So we're going to watch this video that you sent us. It's great. Why don't you set it up for us?
Yeah, so concept we came up with was the concept of what will the world look like when we have unlimited bandwidth and zero latency. And that's what kind of the promise of 5G is supposed to be, that we're going to get that feeling. But fundamentally right now, we don't have that. So to do things like video, which are massive bandwidth users, and putting that on the cloud resources with massive bandwidth didn't make a lot of sense. So what we decided to do was to put the analytics right out in the field. And one of the neat things to do it on was a drone. And we really wanted to demonstrate a few things. One was centralized alarming. The other was actually using a truly distributed architecture. And also that versatility, that there is really no reason why we don't apply SCADA systems to many, many, many different industries like HVAC systems or building management or drones, as opposed to the standard process control and industrial applications we typically tackle.
Gotcha. So, okay, let's jump to the video right now. And Dave, can you jump to that?
All right, thanks very much.
We got involved in a project with you, and it was the University of Calgary capstone project. It's the fourth-year engineering students need a project to go out and test the skills that they've learned in the university. And so one of the things that we were really interested in was Trihedral had come out with a JSON driver for VTScada. And that JSON driver just allows connectivity to all sorts of different products that are starting to come on the marketplace. And so with the students, we kind of put together the scope of work, and we said, hey, what we want to see is when the video analytics detects something that's abnormal or different, that we can therefore alarm it in VTScada. And with that timestamp, we know exactly when the event occurred, and we can go find that on the video if we'd like to watch it again. And where we are right now is we're actually currently looking out the actual face of the drone. We can actually go ahead and map where the drone's going to fly or what pattern it's going to fly on. And so it will now go out and find itself, fly at a little search pattern. And what it's searching for, and this is all automated, it is searching for a blue square. As it takes off up here, it's going to go to the first waypoint, and all the way along the way, it is searching, so the video analytics are running. We use 1,000th to 1,000,000th of the video that we actually take. So when you look at video that's happening at like 6 frames per second or more, all of that data gets stored and put someplace, but nobody ever looks at it because they had no reason to look at it. The only time they need to look at it is when an event occurs. So here we come up, we found the item, an alarm just came in, you can see on the left-hand side into VTScada, telling us that we actually found the blue square. And with that timestamp, we can now reference it back to the video and know exactly where to look. And so that was really the intent of this. Instead of having all sorts of video that we had to constantly stream, so we acknowledged it, and once again, you'll see that alarm come back in again after we've acknowledged it. So the ease of providing this interface was really, really impressive. We did this project on VTScada Lite, which is a 50 tag free license, providing a thin client, allows you to use all the functionality of VTScada. Going back to the fundamentals, we should have a common alarming, we should have common visualization, and we should only really have to train on one product for operations staff. So here we are after a successful journey. This was completely automated. There was no pilot at the helm other than a computer, and we thought it was pretty impressive.
Chris Little and Mervyn Betts.
Hey, Mervyn, that was really cool. So you ultimately decided to use VTScada, which is the free version of our regular software. Tell me, what were the things that led you to make that decision?
Number one, free software is pretty compelling. So VTScada Lite being available was a pretty neat thing to do. We also took it personally on to see what we could do from a challenge for using VTScada Lite. So the amazing piece about what we did there was that using the JSON interface, we actually could control the actual drone. So there was, I'm sure you got that from the video, but there was no human interaction whatsoever. So
That's
because the
cool.
software is easy to use, because it's got a full-blown historian in it and centralized alarming, we really wanted to demonstrate that centralized alarming concept and the ability to be able to analyze the data in the field and then feed that data back to a centralized distribution point. and also to feed back all the historized data where it's flowing and the analytics back into a centralized historian. And that is a very big thing, because as we start to look at these current architectures that we have where we are using edge devices and pushing data, the fundamental question comes back to centralized alarming versus distributed alarming. And if you do a distributed alarming on all different software platforms, the maintenance nightmare is substantial.
Right. So it's really interesting as the idea that the distributed architecture, but also being able to apply that technology literally to indexing a huge volume of video. So it's there's like someone said about a workshop, if you don't know where it is, you don't have it. So being able to jump right to a relevant piece of a giant 24-hour stream video is really something. Also, I'm curious, how did the students do on this project? Did they get a grade for it?
Oh, yeah, they did very well. Yes, they all passed it. In fact, the entire team is working in the automation industry at a couple of our integrators. So, and then one at the University of Calgary. So it was very successful. The team was very good to work with. It was interesting. The VTScada integration part, ironically, took half a day, whereas all the analytics piece took months for them to set up. So that was a real testament to the software and the product.
So this is, presumably this is being used in the water wastewater industry. These blue squares would equate to some kind of anomalous thing in a wastewater situation. What other industries might this be applicable to?
Actually, it's anything. You could be looking for wildlife. You could be looking for gas leaks. You can be tracking pipelines. I mean, the concept of doing the analytics on the drone and then being able to pull that data in, not over a wireless network or over a cellular network or places like that, but being able to move the data when you need to move the data and actually being able to alarm when the instance occurs. Timestamping of the data locally is what really allows this to happen. So that is what the massive change is that we don't need to actually know all the data that happens at that instant. What we need to know is the event that triggers that data. So it could be used for finding forest fires. I mean, there's numerous. Anything that you visually look at and have to inspect and have to compare that against something that's normal versus abnormal, the technology would apply to.
Gotcha. So what was interesting was, at first I thought that this was sort of an interesting implementation of edge technology, like an IoT, but when I was speaking to you yesterday, you were saying that no, this is in fact an alternative to that.
Potentially it can be. So the concept of IoT is to put gateway devices and push all the data back into the cloud. What this does is allow all the processing and analytics to happen right out in the field. Now, one of the things that VTScada lends to this very well is the concept of the distributed architecture, a distributed SCADA system. And to have your historians out in the field so that they're all timestamping the data in real time, but then replicating the essential data back to the centralized SCADA system, that becomes a really interesting discussion to figure out whether you want to go out and put an edge device that has a historian on it and then push all that data back into the cloud, or whether you actually want to go out and put separate historians or different historians out in the field using something like VTScada that we can then access on demand or things like that. So there's a lot of complexity that we can do that actually solves the bandwidth latency problem by deploying SCADA systems out into the field. And it also dramatically improves the reliability because everything is hardwired and local as opposed to having to worry about third-party telcos for data reliability.
Right. That's great. So do you have any ideas for your next project with this class of students? Not these students.
Not these students. Actually, the one that Keith, actually one of your, that runs your Scotland office, he's working on a brewery. And
that's great.
Looking right now.
To cut you off there. Sorry, Mervyn. We'll end it on the beat. So thanks for joining us.
Thank you.
The way, Mervyn Betts M is our distributor in Western Canada. They've been doing really great. Now I'm going to pass you back to Dave. Over to you, Dave.
Thanks very much, guys. That was really interesting. I really like hearing about these abstract cases of VTScada in use that we get different people doing different things, be it telescopes, be it heart research, or be it things like drones and that. And this actually isn't the only drone application that we're going to talk about today. But next up, we're going to be looking at speaking with Travis Smith, who's the Senior Director of Water Marketing at Census. And Travis is going to speak to us briefly. About battery-driven data. So just hang on while I bring Travis on the line here. Chris and Travis, have I got you there?
Yes, I'm here. You here, Travis?
Yes, I am. Thank you very much.
Fantastic.
Thanks for joining us. How are you doing today?
Great. I appreciate being included in today's virtual trade show. It's great to hear some of the stories shared by your partners there. Some great applications there from Mervyn of remote data monitoring.
Oh, glad to have you here. We've of course seen Census and Xylem and you at a number of actual flesh and blood trade shows, so thanks for joining us here. So as we've been talking about different ways of working in the new business environment, how's the last few weeks been for you and everyone at Census? What strategies have been working for you?
Sure, we're trying to keep our employees protected and maintain our commitments to our customers as we serve the water industry primarily, and it's seen as a critical infrastructure. So we're trying to take all those precautions to protect our own employees and still deliver equipment, goods, and services to really help. And a lot of that's focused around remote monitoring services for utilities. So it's been a stressful time, some challenging times, causing us to work a little bit harder, but all for good causes.
That's great. So today we're going to talk about battery-driven data, which again is another thing that when you think about it, you think, of course, batteries are an enormously important part of distributed SCADA systems. So why don't you tell us about that? Sure.
So, what is burgeoning with reduction in costs of batteries as well as improvement of technologies and numerous communications opportunities is really the collection of a lot of data from remote applications, whether that would be an oil and gas pipeline, a water utility, electric utility. A lot of those things might have data that could capture that wouldn't merit the cost of running a dedicated telemetry system or powered system or wiring that up with fiber or Ethernet. So there's a lot of data out there to be captured from remote applications using battery sensors and communications devices. And I just wanted to kind of level set some particular functionalities of the batteries. So there's many types: lead acid batteries, alkaline batteries. Those are common consumer type batteries. Today, most of the things that are fixed asset batteries focus on lithium ion. Often the fixed pieces that are in assets such as water meters or communications cellular modems are lithium thionyl chloride batteries. You also see some activities of lithium ions with rechargeable batteries. Those are types that are commonly found in cell phones or attached to solar collectors, and they may be a viable way to extend the asset life of those devices as well. Something that a lot of people maybe not understand is the environmental conditions that can impact the battery life as significantly as 30%. And it's a challenge to predict the life with all of the seasonal and diurnal patterns exposed to those sensors and communications devices. So you have to account for that in a broad range, as typically things are designed to be applied in many different environmental conditions. Next, the self-discharge of a battery, just the battery itself sitting there and the chemistry associated with its functions, will begin to lose some of the energy over time, and this can be significant. And typically, most of these things, such as the lithium thionyl chloride batteries, may discharge 0.7 to 3% per year. And over 20 years, that could be a significant life or energy expense of that battery, as much as 60%. And then the last group,
Travis.
Thank you. The last group there is the operations, the processor, the diagnostics, the display, the measurement, and then the transmission and receiving times. These are the things that you can control in those designs. And we want to talk just a little bit about that if we'll move to the next slide there. So what is critical there is how the data is going to be used, whether you're just trying to measure it monitor it, trend it, model it, and control. All of those things might dictate what the interval and the amount of data that's needed to be successful in the end application. You may not need 1 minute data to do hydraulic modeling in a water utility, but you may need daily or hourly data. So you want to set that up. If you were trying to do a control algorithm, you may need constant data, and the asset life associated with that device it may be worthwhile to have it be short because of the control nature of what you're doing. The table at the bottom gives some simple data factors just to what you were looking for in a common water utility application, but could be applied to a gas and oil pipeline or any other remote utility application. And these things can multiply rather quickly by the number of endpoints that you have, as this would represent a single endpoint over time. So it begins to become a significant volume. And some of the keys here are to manage that data volume against the end use. And if we flip over to the next slide, we'll talk a little bit further about that. So as you look at the data interval, and there's two different things here. There's the measurement interval and then the latency of the communications to the analytics device. You have to consider the rate of change. For example, is 1 minute temperature data meaningful? Well, it might be if you're controlling a steam boiler. It probably isn't if you're controlling a water utility pipeline or service line. You might only need hourly or daily or 4-hour buckets. Again, consider the use case. Consider whether it's trend, monitor, model, control, because they all have different values associated with it. Consider the critical nature of the application. So it may be very, very worthwhile to monitor more frequently and shorten the asset life of a battery component based on what you're measuring. For example, a water leak has one critical niche nature versus a gas leak. So the risk associated with monitoring and detecting a gas leak may merit the shortening of the battery life and the association. Whereas a water leak, you may want to have a longer value proposition with your devices. And as we heard earlier, consider the edge processing capability, normal versus abnormal. And today we're in a very abnormal condition. We're going to the CDC, checking on the COVID-19 cases and what's the latest data. We're interested in that because it's an abnormal condition. Whereas 2018, we probably were not checking that unless it was something in your domain or work expertise. Well, the same thing applies to monitoring a situation. You may want to collapse your data in the field, run edge processing, hold it there, and save the transmission battery assets for abnormal conditions and be able to dial that in. When it's an abnormal condition, you may want to change from an hourly to a minute frequency to capture more information to improve the situation and then return to a normal threshold of data volumes and latencies to maximize your asset life. Because if we look on the right side there, every time we have to deploy new equipment and we expend that battery life, we have to look at the asset and the CapEx of the sensors, the communications, the install, and we also have to consider what the OpEx driving is. Do we have to run power there, the transmission, the storage, the security? How much expense are we divulging on the data scientists and the analysts to operate that data? And what could that drive in terms of asset life here? So as we just to illustrate the point here on the normal versus abnormal, because I think the future will be data your way to vary the volume by the use to optimize the asset life. So if you have normal conditions, you're not going to send a lot of data. You're not going to look at it very often. But when you get to an abnormal situation, that's when people are going to want higher resolution, monitoring, closer following, and then be able to return to a normal condition.
Gotcha. So it's kind of the equivalent in the Scada world to setting an appropriate polling rate. Our concern is being able to only record meaningful changes in historical data. But in this case, you need to have a strategy. You can't just measure everything all the time. The battery just won't sustain that.
That's correct. That's a great analogy there, because the cost of draining the battery has more than the device itself and can be significant. So you want that flexibility to be able to fix the problem, but you want the flexibility to maximize your asset life.
Gotcha. Well, thank you, Travis. You moved through all of that really well. Thank you so much. If people want to learn more, go down to the link in the description to talk more about Travis. Now, back over to you, Dave.
Thank you.
Thank you.
Thanks, Travis. That was really interesting. Next up, we're going to make a fairly quick diversion over to Blair Suley, who's going to talk to us about VTScada version control. Now, Blair is the regional manager for the Texas area for Trihedral Engineering. Let's just bring Blair on the line.
Hi, guys. Can you hear me?
Hey, guys. Yeah, we got you here.
Hey, Blair.
Yeah, great. So, yeah, I wanted to touch...
Thanks for joining us. And by the way, congratulations on the City of Houston.
Oh, thank you very much. I appreciate that. It's going well. So what I wanted to look at today was really, we're talking productivity tools here. So I wanted to keep along that line of how you might stay productive at home, specifically in a certain situation where you might not be able to get to site in order to make your changes to an application. And you might have limited access with security parameters around applications such as pipeline applications and such, where they might have to enable a remote connection in so you can do your work. So how do you stay effective and organized during this time? The key is that you utilize something like our application version control. This allows you to ensure that all configuration changes are recorded and they're traceable. Everybody knows who made what changes when and exactly what those changes are. Network application integrity is enforced using this process, in that all Scada nodes, whether they be servers or clients, are automatically updated and ensured to be synchronized, all running exactly the same application. There are products out there that allow you to upgrade one or update the version on one node and not others, which creates a potential major problem within your system. All data is logged to a repository and it's tamper-proofed. We tamper-proof it by using a level of encryption. It's a military level 256-bit SHA-2 and all that good technical detail. If anyone wants to get into that, please feel free to send in questions. And finally, how do we further protect that from loss? We distribute the repository to multiple locations, and we keep those multiple locations synchronized. Next slide, please. Okay, so this is an example of how you might stay productive using remote change management, which is a subset of functionality within the version control system. You can either make changes online or offline. So online would be that you typically in a lot of situations you would have to log into something, say via remote desktop, which limits the number of users who can develop on the application. In our case, what we do is to allow users to develop on their development nodes on their own computers. All system integrators for VTScada have them, and some end users have them as well. You make changes there, and then those changes are synchronized with the main application. It works either in automatic mode, meaning all the changes are automatically synchronized as they're being made, or an on-demand mode, where you make changes and then you selectively choose which changes are to be deployed out to the rest of the application network. And authentication is absolutely essential for this. So you cannot deploy any changes that are not authenticated. Excuse me. In a situation we're showing here, it's a multi-user configuration environment. So if you look at item 1, graphic 1, you've got 2 users who are making changes. They could be remote users. One could be remote, like a system integrator, and one could be an on-site user. You can have as many of those as you like. In situation 2, they both connect to the main server and they synchronize their changes back up to the server. In situation 3, they then get a full copy of the complements of all changes made by all users. Thus, we now have a fully synchronized system where any future changes are based on the system as it currently stands, and conflicts are managed during this situation. Next slide, please. Thank you. So this is a version log. This is essentially the visualization of the versions and the version changes that are occurring. What you're looking at here is the one that's highlighted is Blair-Laptop, which is my application, the one that I'm running here. And it shows me that one is currently running the current released version of the application. That's Blair-Laptop-66 under the current version. Note that it was released on February 28th, 2020. And it's in black, which means it is the latest running version of all of the versions that have been deployed. It also indicates that there are 4 other computers that at one point in time, this node synchronized with. So imagine I'm the server and these are additional servers or workstations that were brought on at one point. And they synchronized at this point back in Wednesday, September 25th. They were running Glenn Wadden-D25 and one was running Glenn Wadden-D19 on the 24th. This just happened to be during the WEFTech show, which was a time at which all of these marketing computers got together and we synchronized on one app. Well, in a real life situation, these would all be black, meaning that they would all be running the same current version of the application. Any that are red, as shown here, means they're running an outdated version. Now, as soon as they connect, they should automatically synchronize and get the changes, and you'll see them turn black. There's one additional color, which is key. Actually, if you can go back to that last one there, one additional color that's key, which is the blue. And blue means that there are changes that have been undeployed. Now, on the version log below, you'll see that there are many changes that have been made by many different users from various computers. And if I click on any of the workstations in the workstation list above, I will see exactly which versions have been deployed on each workstation. Next slide, please. Okay, when you give this kind of capability and this kind of power to have many users who are deploying many different versions, branches into a key trunk, what you will end up with is the potential for someone who makes a change and you have to remove that change. Let's say we're all making a bunch of changes today. Yesterday, things were going well. And during the day, at some point, something happened that caused the system to act in an anomalous type of condition. What we would like to be able to do is either selectively reverse versions changes, as we've got shown here, with server 1-D73 being reversed, or switch completely to a current or to a version that was running, which is the option just above it. So I can switch to a version that was running the previous day. When I run a reverse version changes, you then see the graphic to the right. And what you're seeing here is that I've selected just one of the 2 files that was changed during this version change, and that page is overview.src, which is a source file for one of my graphics. That indicates which changes were associated with that version, which is those in green were additions, those in yellow were deletions. When I select to reverse that version's changes, it will take that incremental change set and remove that from the application. And that then gets deployed to all of the users. Okay, so this is a great way to manage your changes. Then finally, when we have this set of tools, we can further expand these by taking advantage of them to import scripts and non-VTScada files. So something like if I have binary files, if I have bitmaps, if I have maybe a file that was used to configure a device that's within my system, I include these in. So I just wanted to cover that. Thank you very much for that time. And that's what I have.
That's great. So thanks for joining us. Best of luck. I know things are going really great in our office down in Houston. Have a great day. Tossing back to Dave, and we'll look at what's coming up in the next hour.
Thank you, gentlemen. Take care.
Thanks, Blair. That was really great. Next up, we're going to be speaking to, just cover my audio sources here. Next up. Oh, I'm sorry. Let me just jump back here. Next up, Chris and I will be speaking about what's going to happen in the next 30 minutes. And as I was just about to jump in with, we'll be starting next with advanced reporting and dashboards with Dream Reports. And Chris, do you want to cover the next one?
Also, take a peek at the future of a video that Dave and I worked on together a few years ago about augmented reality, a little peek into the future. And also, we're going to talk to Signal Fire Telemetry Inc. About their flexible and cost-effective wireless SCADA platform.
All right, thanks very much, Chris. Next up, as was just noted, we're going to be going to Roy Cook of Ocean Data Systems, and he's going to be talking... Yes? Roy is going to be talking about reports and dashboards. So let's just jump over to the view here and try to bring Roy into the conversation.
I'm with you. Good morning.
Hi, Roy. Thanks for tuning in. How are you doing today?
I'm very good. Thanks for having me.
I'm glad to have you here. So how are you guys? I'm asking this question to everybody. What tips, techniques, software platforms, ways of communication are you using to kind of adapt to the world being the way it is? We're all working from our desks and dining room tables.
Yeah, good question. This is actually our normal mode of operation. Ocean Data Systems is a pretty modern internet-based company. Our headquarters are in Israel, but we have other people in 6 other countries, and we all work from home offices. We use WebEx, Zoom, Skype, TeamViewer, all the typical tools to help support our customers and help develop business. So it's another day for me.
Oh, that's great. So I guess we've known each other for a while now, off and on. I've seen you again at a number of real trade shows. You actually presented in our booth a few years ago, I believe, at LeftTech, I think. So I guess it's important to make a differentiation between the kind of reporting. So VTScada, our software, has built-in reporting in it, but this is a third-party reporting package. Can you talk a little bit about the value proposition of Dream Report versus the integrated reporting that any SCADA system has?
Thank you for that. And yes, so we've been partnered with Trihedral since 2014, and you can think of Dream Report as a product that delivers advanced reporting and dashboards, a much more detailed level of KPIs.
Right.
And we've worked with our product over the period of years to target various vertical markets. So when it comes to dealing with compliance reporting, that's often needed for water, wastewater EPA reports, FDA reports in the pharmaceutical, food, biotech space. We do that extremely well. We're very focused on compliance reporting. In addition, though, we do a lot of performance reporting. So that would be the various reports you want for the KPIs most important to you to run your business better. So Dream Report can generate downtime reports, energy utilization reports, production reports, anomaly reports, ISA 18.2 alarm statistics, any kind of information that you need to run your business better. And then we also offer a lot of tools in Dream Report to be able to troubleshoot your data. If you see a KPI that's wrong, you'd like to pull up a tag out of your historian, you'd like to pan and zoom and export data, bring it into an Excel package to analyze it further, and you get those tools as well. From a reporting perspective, Dream Report generates a lot of different types of data for you. We can generate PDF files, Excel files, CSV files. A lot of data needs to be transferred to other systems, and we generate XML documents for that purpose. And from a dashboard perspective, we generate HTML5 web pages. And in addition to generating documents, we do a lot of document management for you. So we have the ability to drop files into directories, name those directories by year or month. We can transfer files to remote locations using file transfer protocol. We can email documents, and all of that can be done on time or event. Not everything is time-based. Dream Report is very good at batch reporting. And to us, a batch is anything with an indeterminate start or end time. So Dream Report has the ability of detecting start times, end times, naming those events. It could be the running of a backup generator. It could be a pharmaceutical batch. And then Dream Report can generate all of the statistics you need across those various events. And again, over the years, we've enhanced the product and made it a perfect fit for every vertical market. As we create functionality for one vertical market, we generally put it into the product in a way that it's a benefit to all markets. So if you transfer to the next slide, let me tell you a little bit about the success of Dream Report, and then I can finish by telling you a bit of the unique capabilities that we have in the product.
Sounds great.
Thanks. So, success of Dream Report. Again, we've been doing this for over 15 years. If you log on to our YouTube channel, you can find that on our website. You'll see a great video from our very first customer, a company called Vasilico Cement, and they're on the island of Cyprus off Greece. So being an Israeli-based company, obviously we need to supply product to the rest of the world. Dream Report's available in 14 different languages. Our team has put over 150 person years of development into the product, and we have it installed globally in over 11,000 locations. With over 25 releases we've had to date, we've tailored it to be a perfect fit for every vertical market. So I can tell you it's honestly a really good fit for every water and wastewater application, pharmaceutical, general manufacturing, building automation, and pretty much any other application you can think of. What makes it a bit significant is how we go to market. We're a small company, yet we have a very large footprint in the world. And we do that by partnering with a lot of other name brands that you'd recognize out there. We have OEM relationships, and those companies private label our software, and they sell it and support it as it were their own development. A quick Google search can show you many of the brands that have standardized on our product. Other companies like Trihedral choose to recommend Dream Report for applications when it's a good fit. And for that, we have our proven partner program. And again, Trihedral has been a proven partner since 2014. Through all these relationships, over 24 to date, Dream Report's become the most resold and recommended reporting product in our industry. And fortunately, it shows. Dream Report has won the most coveted award in our industry now for 3 years in a row. That's the Control Engineering. Yeah, thank you. That's the Control Engineering Engineer's Choice Award. And as you see, as we'll, if you explore Dream Report further, you'll see that it's fairly priced, very scalable, and it's a great addition to every application. All right, so the key features in Dream Report that makes it very significant. First of all, we're delivering a product for industrial use, and it has all of the features you'd expect to see. Our target customer is the process engineer, not domain IT experts, but process engineers, folks that want to configure solutions. You can't report on something unless you connect to it. So the biggest differentiator in Dream Report is having over 100 different drivers to connect to data sources. VTScada is just three of our 100 drivers. We can connect up to real-time data, to history data, and to alarm and event data from VTScada, and then generate any kind of statistics, reports, and dashboards that you might need. Process engineers don't want to do programming and scripting, and Dream Report doesn't require that. We have it under the hood if there are advanced features you'd like to have. But ease of use is one of our key criteria. We have lots of templates in the product, in fact, over 80 templates, so you don't have to start from scratch. You can build with what we have in the product, copying and pasting and building up your own application very quickly. It's a really straightforward product to use, well documented, over 600-page manual. You can download our product off our website, send us an email, we'll give you a trial license, and it'll be the right solution to add into any application. There's really nothing else like Dream Report on the market.
That's great. Thanks so much for covering all that material. And I look forward to seeing you again at the next actual flesh and blood trade show.
Thank you. I look forward to it. Take care.
Now, if people want to learn more about Dream Reports, you can again look down. I haven't mentioned this each time, but down in the description of our live stream, there are links to Dream Report as well as to all of the other people who will be presenting here today. So thanks again. Have a great day. And I pass you back to our host, David.
Hey guys, thanks very much. That was really interesting. I know that, yeah, we see these guys a lot at the trade shows and other places, as well as a bunch of the vendors that we're having today. So it was nice to actually interface with them and get to chat with them a little bit yesterday while we're getting ready for this. So next up, you know, as we're all practicing a little bit of social distancing, we decided it would be neat to take a second look at an older video that we had on the HoloLens, and because the HoloLens really provides a unique tool to actually solve some of these problems. So let's just jump over to the HoloLens video right now. Give me a second while I queue it up. You'll see in this video is the HoloLens running today's VTScada thin client as projected holograms. I hope you enjoy it.
I'm the manager of operations for water and wastewater treatment for the town of Windsor. That includes overseeing all aspects of the day-to-day operations for our water treatment and 2 wastewater treatment facilities. I've been with the town for 10 years. I've been in this position for 2 years. Incredibly interesting. The industry's changing constantly. As we do daily rounds through the water plant, we have a long check sheet that we go through every day and on weekends as well, and we check every system in the plant, every pump, every chemical feed. So I think it would be pretty cool to be able to walk through the whole water plant with this on and look at every piece of equipment through the eyes of real-time data, you know, instead of you know, just your general look, listen, and feel, you know, and writing numbers down on a chemical feed pump, or you know, amperages on a motor, you know, to be able to physically look at everything in your facility, and it shows those amperages and run times and alarm statuses as you look at that piece of equipment. I think it's a mind-boggling, you know, technology. I think the augmented reality is a pretty neat concept. You know, again, like to have all that at your fingertips is that's a pretty cool thing. You know, the way of the old school operator is slowly dissipating. You know, the more conferences and courses and information sessions that I attend, there's a continuing trend of younger operators that are a little more comfortable with technology. You know, just the guys that I work with, we're all roughly the same age, and we're all kind of on board with trying out the latest and greatest. You know, going from our new wastewater facility with the technologies we're using there to one of the first utilities to be using all the Scada. You know, so I think it would be well received. Obviously, there's you know, a substantial amount of training that would have to be involved there, you know, for everybody to come comfortable with it, and you're bound to have a few staff members, I think, that are gonna have some hard times with it, but I think in general it'd be quite well received. I did notice, you know, like just trying to get your fingers like just just becoming accustomed to it, I guess, is the biggest hurdle for anybody, and to convince them that it's a good thing and that it's a good tool. And when I first started, I was overwhelmed with just the Scada coming from what I was using and from my last job, and it was a bit of an undertaking to learn that and become comfortable with it. But once you got it, I couldn't operate without it anymore. And I think something like this, in 20 years' time, might be somebody could be sitting there saying the exact same thing. Like without having a HoloLens on my head walking through my plant, how could I ever know what's going on? So it's a pretty neat technology.
All right, thanks very much, guys. That was Martin from the town of Windsor, talking about his experience with the HoloLens. I thought that was really neat. There's another side to the HoloLens that we didn't really cover in that video. That video was much more about putting your plant sort of in action. But we also had a little bit of a unique experience with the HoloLens, where we're able to use the HoloLens as a sort of being away, but giving instructions to somebody where they're able to see the actual video through the headpiece, and then we're able to work with that and actually give instructions to an operator or somebody on staff. So you can have an engineer or somebody anywhere in the world talking to somebody who's actually performing those actions, in the third party.
I look forward to our support, being able to offer support in this way.
Right, so next up, I think we've got kind of a fun part of this.
Yes. Okay, everybody, so it's time to open up your emails, and I want you to type in this email address, Natasha Lutz. Hi, Natasha. Type this email in, and then the phrase above it, instantly intuitive, is the unique code phrase, and we're actually going to give away $200 online in the subject matter. So put instantly intuitive in the subject line. And we will draw two different people from that list, and each of them will win a $100 online shopping voucher. So do that now, and I'm going to toss back to Dave.
All right, thanks very much, Chris. So we're going to proceed along fairly quickly here. We're not going to spend a whole lot of time in the intermission here. Next up, we're going to be speaking with Kevin Smith. Kevin is coming to us from SignalFire. And I'm just going to cue Kevin in here. And Kevin, do we have you on the line?
Yes, I'm here.
Great.
Great. Well, thanks for joining us today. So I'll ask you the same question. What kinds of software or techniques are you using to adapt to the new business climate?
Within this trade show? Or within the product?
Yeah, like for example, we have this virtual trade show as a way of being able to do some of the things that we could do, except do them from our desks.
I don't understand the question.
Oh, that's okay. So tell us a little bit about what you do at SignalFire and what your job is.
Yes, I'm the Southeastern Regional Manager over the southern eastern part of the United States, Caribbean, and Mexico. And I have over 25 years of automation experience. And I've been with SignalFire for over a year, selling and supporting their existing 900 megahertz system. And as of the first of the year, selling the new cellular-based IoT sensor-to-cloud product called the Ranger, which I'm going to go over today.
Great. So just let me know when you need me to advance the slides.
Okay, so what is the Ranger? It is an IoT cellular transmitter that communicates over the latest cellular technology called the LT Cat M1. And we can communicate to our server, or we open it up to be able to communicate to a private cloud server. It can connect to multiple types of I/O, where we have analog, where you have 1 to 5 volt analog signal, or 4 to 20. Has digitals to where you could put on-off switches, and then we have an output on a unit to where you can send out a relay output to control pumps, valves, lights. We also have an expansion board slot that you can, we have plans to add more I/O and also HARP and also Modbus. Within our server, we can fully configure it. On the digitals, we have it to where it can report by exception whenever they have a change of state. And then on all the other data, we have a check-in interval that ranges from 1 minute to 60 minutes. So if you want to click next. So with the connectivity of the sensor to the cloud, we broadcast the signal using what is called MQTT Sparkplug-B to a server like ours that can communicate that, and then, like I said, to a private server. It has TLS internet security to where you can set it or not. Our server is hosted by Amazon Web Services. And as far as the cellular connection, we use within the states Verizon and AT&T, and it's globally recognized, and it's been tested with PTC RB Lab for use across the world. So if you want to click next. So this is an example of some software that communicates MQTT Sparkplug-B, but we are working with VTScada with Autosolve to communicate to its server over this protocol, but then over to VT's server using OPC. And in an application, water wastewater application that I'm going to talk about in a little bit, we are using a local software company called CPUs, MQTT IO server to pass the data over to a local Scada server using OPC UA. So if you want to click next. If you open up the product, this is what you'll see. The curved area is the antenna. To the right is where they have a SIM card slot, where when you're communicating to our server, we include that. If you're communicating to a private server, you can purchase it without the SIM card and be able to add your own. Below it, the blue is a battery, and they have a connection there. We have other options where you have a solar panel or a DC to DC converter. To the left of that connection is a terminal block where you can feed your I/O from the bottom half-inch NPT connection to the terminal block, and then to the right above that terminal block, we have a latch-in relay for the output to conserve energy. To the left of the terminal block, they have the micro USB config port where you can locally configure it with our toolkit. And right behind the terminal block, they have a SD card used for storage in the future for like data logging. The expansion board slot in the center will allow us to connect to additional I/O into the HART and Modbus. This slide shows you an example of our server where it has very basic visualization of the I/O. Right has GPS coordinates and signal. If you scroll down in the application, you would see a trending graph, or you can have it in a tabular format. You can save that to a CSV file, and then we save this data for 3 years. So if you want to, and then below that, you have configuration of the units, and then also connect the configuration to send out text and emails. If you want to, here's application that we have a radar connected to the Ranger that is for a chemical chemical tank out in the middle of nowhere where they have a cellular connection. So if you want to click next. And here's where You would specify it based off the power. If you want the interface via the I/O, and then it comes connected to our cloud with the data included, but then after that, you can have it for 2 years, 2-year packages or per month.
That's great. That's sort of.
It looks like the slide that I had for the application for water wastewater is not in there, but we have an application that we're doing for Jefferson Parish that is communicating to a local VTScada, and we're deploying that right now. So if you're interested in the product, we have a test drive website connection here. If you go to our website, www.signal-fire.com, you can test drive it. And also they have a form on our website where if you have an application and you're interested in it, you can fill it out and we can contact you.
That's great. So you had mentioned that this technology supports LTE Cat M1. Do you support other communication technologies?
No, that is the only one that this product communicates. So will not communicate 2G, 3G. The LTE is 4G, and it's made for the IoT communication to the cloud, but it also won't communicate 5G. So it's only that protocol, that technology. In the last minute that we have, just tell us a little bit about who is looking for this technology. Who watching today would sit up and go, yes, that's the solution to my problem? Yes, so it's interesting because on our other product line, we have it to where you communicate to a gateway, and it can get a little costly when you have one point of data that you want to get. So this fills the gap for just really one point of data that you want to collect the data, and you have a cellular connection. It's opened a door for us to get into more water, wastewater, and agricultural markets. And then also just managing where and what the levels are for pumps and rental pumps and rental generators. So it's really a product that a lot of customers are thinking of different applications for.
Excellent. Well said. Well, once again, thanks for joining us today. And I wish you the best of luck. And if anyone would like to know more about Kevin Smith and the work that Signal Fire Wireless Telemetry is doing, again, please go down and look at the direct link in the description below. Thanks for joining us, Kevin.
All right. Thank you.
And over to you, Dave. How are you holding up, Dave?
Things are pretty good with me. The next slide, I'm hoping will highlight the next 30 minutes, what's happening here. Is that true?
Yes, it is true. And there it is.
Fantastic.
And boom.
All right, so in a few minutes, we'll be talking about scalability with Alan Hudson. And after that, we'll get into the advanced flow meters with Endres and Hauser, and then SCADA architecture with Pat Cook. So if you're waiting for any of these, hang on the line very soon. And I'm just going to jump into the view here.
And I'm going to advance
and
the
we're going
slide.
to talk. So just wait for me to queue up Alan. And there we go. We're coming in. Alan Hudson, do we have you on the line?
Hey, fantastic. It's good to hear from you guys today and have some social interaction, even though we are physically apart. That's a great thing. Dave, one of the things I've been enjoying watching as you've come back on the screen over and over and over, I keep looking at that picture behind your head. I don't mean the one with the banner. I mean the one with the Volkswagen Bug. And if we want to look at what this virus is really doing, you're there at the beach. You have the whole stack of surfboards above the top of that Volkswagen Bug, and nobody is surfing. So that's what I call being quarantined for sure.
Yeah, that's right. There's a lot. One of those surfboards could be missing.
That's right. That is right. Well, I know this is causing a lot of difficulty with a lot of people. Since I work out of the house all the time anyway, the only thing for me is I'm used to traveling. I'm used to getting on an airplane or being in front of customers, sitting around a table, walking a plant, perhaps being in a hotel room. So for me, the difference is I'm sitting at the same location over and over and over. And a guy like me with ADDDD is having a really tough time. But on the other side of things, it is fun. It has actually caused me to look a little closer into what I'm doing. I've had a number of conference calls and webinars that, again, normally I would have held in person, Chris, and yet I'm doing those things remotely. It causes some frustrations. It also causes me to be in more places more quickly than other times. And to me, that's one of the beauties of what we're seeing with this transition of time right now. I know that the travel bans and things will be lifted later on, and when that happens, we'll probably work a little smarter, perhaps. Certainly, I know it'll help me from thinking about how folks around me are also moving forward with a number of things. So,
it's true. It'll be interesting to see what carries on, what changes carry on after this.
That's right. And so what you've asked me to look at or talk about for just a few moments is in this term of scalability. And if I think about scalability, even from what I'm having to do today, again, if I'm going and I'm meeting with people, physically driving from location to location, I can only see so many people per day or so many locations per day. Right. And yet doing it this way, I can touch a whole lot more. Granted, I lose some of that connection that I would have had otherwise. But that's why I want to take what I'm talking about with scalability, in particular with our automation and controls, and talk about it from that perspective. But I really want to draw that in to how it looks, or maybe can correlate to our quarantine time. So if you go to the next slide, I'll just give a quick overview of what we're looking at for these next few minutes. So as this comes up on your screen, we've got a couple of things that when we look at SCADA systems in general, I go back to 30 years ago when I first started doing automation and control, and I'm in various plants around the Southeast in particular. And computers were coming about. It was DOS days. It was early Windows days. It was early days of PLCs when things were still very difficult in many cases to operate. They were still expensive as well. And it was, how do I take this and really plan for the future in a way that makes great sense? Well, we're in a whole different age these days with technology. You know, if I look at stores being open today, one of the stores that can be open in Alabama, where we have a stay-at-home order or directive, is technology stores can still stay open. So can building hardware type stores. If I look at that in relation to what we're doing in water and wastewater, the same thing occurs. You know, we design for a situation we have today, and yet we have to migrate in the future. And so if I look at a plant, for example, we're going to be adding remote devices. I mean, we just heard from Signal Fire talking about that. We heard from others that have talked about adding those other devices. We look at increasing our I/O points. You know, how many things we're going to be bringing into the conversation as far as data analytics. We look at other users wanting to come in to the computer environment to grab information. Same thing with reports and dashboards. We heard that a moment ago from Dream Reports the same way. Then how do you can do the data analysis? So let's go to the next slide. And let me bring this into again, a little real thing here. So if you're from the Southeast U.S., that is, you understand Little Debbie cakes. I'm a fan of Little Debbie cakes, and lots of different varieties, by the way. I saw this meme. I thought it was really quite cute and quite telling. You know, before the quarantine, here's how you look, and maybe after, here's how you look. So again, we get a chuckle out of that. But what I want to point out there from my thought is, well, I don't know, is maybe hasn't showed up on the YouTube side of things. I'm looking at that as well. But what ends up happening there is that before a need arises, you need to be thinking ahead about what you're going to do with this. In the case of the COVID-19, did you have a chance to plan out a menu before you went to the store? I mean, clearly you were looking for things like toilet paper, which were not to be found. But what about other things as well? Was it haphazard and you just had to get what you got? Or did you actually have a plan in mind? All that wraps around a discipline. So go to the next slide, Chris, and I'll continue this and wrap it back into to this part of things. So as your slide is, yeah. And so what we're looking at here on scalability within Scada and Scada software and Scada hardware is we're adding PLCs, we're adding devices. Maybe we add a VFD that has 120 data points that I can read out of it serially. So how do you go and add that to your Scada system? Well, there's really two different mechanisms. One is, do you have enough capacity within your licensing for that to happen? And I know with the VTScada world, but I really hear from customers that talk about that so positively is when they upgrade from one bandwidth up to the next band of I/O tags and quantities, then what we end up having there is really nothing. You only have to pay the difference between those different quantities. That actually makes upgrading extremely cost effective and really seamless from that standpoint. The same thing with having multiple protocols built in. If I choose brand X now, when I've been using brand Y for the last 5 years, is that going to cost me more money? And the answer is, if device drivers are included, then the answer is no, it all comes in. But that scalability within the VTScada environment makes a bunch of sense. There's not a penalty, so to speak, for internal tags or extra screens and those kinds of things. Go to the next slide, if you would, and we'll finish this part out talking about concurrent thin client connections. You know, one of the things that happens in our world today is one person realizes what they can do with the software, and the next thing they're going to do is have their buddy in the next cubicle over, the next office, who says, well, I want some of that data as well. How do we add another connection to that? Again, be able to quickly and effectively upgrade that and seamlessly do that is such an important aspect of a scalability. The same thing for reports. How can I quickly add reports? How can I quickly do some dashboards? How can I make it to where the manager that needs to see this can see it? And then finally, the same thing with the data analysis that you want. But all of these things come into play of thinking ahead about it, knowing what you want to do ahead of time. And even though you're going to have some unforeseen situations thrown at you, having a Scada software in this particular case that can quickly change and modify is very, very important. So with that being said, I think my time's about up, Chris. So
actually, we've got lots of time. We've got about 2 minutes.
Oh, do I really?
So
man, I have.
You've done really well. You covered that. So I guess I would just say, what advice would you have for someone looking, taking this opportunity to look back at their process, and what recommendations would you make to them?
Yeah, that's a great point. And actually, this conversation came up earlier this morning in a conference call that I was having for a particular project. And what they were looking at was, they were asking me, said, okay, Alan, we want to now take this. We're doubling the size of our plant. What do I need to do for my software? And I went and pulled up our price sheet off of our website, and went through that with them and said, all we're looking at paying is just the difference. Since you're up to date on your Support Plus, the only thing you pay is the difference between prices. And it made it where just for a few $1,000s, all of a sudden they are able to double the size or triple the size of their software ability or availability. And it made it to where when it comes to looking at this upgrade of their system and of their plant, it makes it almost just a very small drop in the bucket as far as our side's concerned. But that became because they had started thinking about this or planning ahead or making the right decisions about 6 or 7 years ago. Another customer came and said, you know, we have 3 people right now that are linked in with their remote devices on their cell phone, they're from home or whatever. They're now increasing the number of technicians, the amount of people that need to be able to connect in from home, especially as they are having to adapt right now into a work remotely environment. So that's how that's working.
You fit that in perfectly, and it gives me just a bit of time for joining us. And have a great day, and we pass it back to Dave.
Thanks, Chris.
Sorry. Next up, we're going to be talking a little bit about some cutting-edge technologies. And to do that, we're going to be speaking with Robert Villarreal from Endress and Hauser. And I'm just going to bring Robert on here. Robert, are you with us?
Hi, Robert.
Hey, good morning. I was muted there. Sorry about that.
No problem. Now, Robert, I want to apologize. What we're looking at on the screen right now is the slide I missed. I from all directions, so I kept meaning go back and fix Robert's slide. Anyway, thanks for joining us today. How's everything going on your end?
Everything's great so far. Kind of adjusting to working from a computer screen more than being in the field, which is a little bit of an adjustment. We're still up and running. We're still being able to focus on supporting our customers in the field. We're using things like FaceTime and real wear glasses, which are little cameras that tie into safety glasses on our service side.
That's cool.
Allowing them to kind of connect with the customer and see what they're seeing through their eyes. So although I know we're all kind of quarantined in place, a lot of us are, we're still able to use some of this really cool new technology to sort of still reach our customers and still be able to support them, which is nice.
That's great. So tell us a little bit about what we're going to talk about today.
Yeah, so Anderson Hauser is a global instrumentation manufacturer. We do flow, level, pressure, temperature, liquid analysis, any sort of online measurement device. My role with Anderson Hauser is to focus primarily on the environmental industry. So I do mostly industrial and municipal wastewater in the Midwest. So today we're going to cover two core technology advances that directly impact a couple of key measurements for the environmental industry. They apply as well in other industries, but they're really important for environmental. So the two topics we're going to cover are some unrestricted mounting magnetic flow meter technology. And then we also have newer digital sensor technology for our online analytical devices. So to start with here, man, you really queued that slide up at a perfect time. I'd like to share with you guys a new option that we have for our ProMag W meters, which is the world's first electromagnetic flow meter for unrestricted measurement. And if you'll click on the next slide, we'll kind of go over what that means and go into some details. So to get into this a little bit, one of the biggest challenges of flow measurement technology is generally the installation and the straight pipe requirements that are required to get an accurate flow meter reading. Typically for magnetic flow meters, the industry standard is to require 5 times the diameter of the pipe in straight run before and 2 times the diameter of the pipe after the meter to ensure laminar flow so that we can get an accurate measurement. So what it looks like if you look in this picture above, whenever it comes around a bend, the flow profile is kind of all jumbled in the straight section right after an elbow. So for example, a 10-inch line size flow meter would require 50 inches of straight pipe ahead of it, or a 20-inch line size meter would require 100 inches. So as you get into larger line sizes, it becomes more challenging to install a mag meter to get a good, accurate flow reading. So if you want to click on the next slide. So in the past, what Anderson Hauser and other manufacturers have done to address this is we've either used a flow conditioner of some sort in front of a mag meter or in front of a flow meter, or we've reduced or constricted the diameter of the central section of the By adding additional electrodes and enhancing our transmitter technology, we can now do this with a full bore meter design. So there are no limitations on the installation or performance of the meter. We can now install our mag meters directly after 90-degree bends, open valves, things like that with no impact on meter accuracy. Click on the next slide. So an example of this, and one place that we've utilized this technology the most is at the water treatment level, either distribution or at the treatment facility. A lot of times what you run into is you have such a narrow footprint, you're trying to expand treatment or expand flow through capabilities, and sometimes it can be difficult to find enough room to design additional straight run section of the pipe to get an accurate flow measurement. So this zero straight run unrestricted flow design solves this problem. If you look at the picture here, it's a very tight installation, has a 90-degree bend coming in and out of the meter, And on this installation, we have no loss of accuracy at the meter. So it's a very good technology advance for flow metering. So the next technology that I wanted to share with you all is how our online liquid analysis products have kind of upgraded to using a digital protocol that simplifies the operation, the maintenance, and increases some of the sensor life because it gets rid of some of the limitations of analog sensors in the field. We call this technology MemoSense, and it's available on any of our online liquid analysis sensors, pH, DO, or P and turbidity, for example. Click on the next slide. So traditionally, some of the limitations of analog probes that we have corrected with this technology are exposed metal pins that may be prone to corrosion, depending on the environment or moisture ingress, signal noise or ground loop issues that you may run into on the electrical connection, complex wiring or additional preamps and power in a way to isolate the sensitive millivolt signals. And the last major limitation of traditional analog sensors for online analysis is that they have to be connected and calibrated in loop with the transmitter to do a field calibration, which is sort of a limitation. Next slide, please. To resolve this, what we've done is basically we've made a digital connection with the sensor and the cable. So MemoSense technology solves these problems. If you look at the image here, both the sensor side on the left and the cable side on the right are fully hermetically sealed connectors. There are no exposed connection points, no exposed pins. They're both kind of plastic housings. So this prevents any water corrosion or water ingress or corrosion problems at the point of the connection. We use inductive coupling between the sensor and the cable to provide power and signal transmission. So there's no wiring that occurs when you plug in the sensor. It's a simple kind of quarter turn connection, and you don't have to worry about damaging pins. In addition to that, all of the analog to digital conversion is being done at the sensor itself instead of at the transmitter. And we're only transmitting that digital signal back up to the transmitter. We store all the sensor information at the sensor so you can calibrate these probes, something like a pH probe, offline in a lab or a benchtop setting. And then whenever you need to calibrate one in the field, you can simply take it out into the field and swap it out. That calibration curve jumps all the way up to the transmitter level. It uploads it automatically and recognizes it when you plug it in. So this can save on a lot of maintenance and a lot of lifetime issues in the field. As you can see here, due to the sensor technology and due to using a digital protocol from the sensor to the transmitter, we can connect up to 8 different channels, and we can export them or output them all via an Ethernet protocol. So our transmitters are all Ethernet ready to make it simplifying for field wiring. Instead of doing a bunch of twisted pairs for 4-20s, we can do one Ethernet connection. We also do the traditional 4-20 design as well. So we're trying to simplify this a little bit for the future.
All right, sorry about that. There's an auto advance on the website slide.
Oh, okay.
So that's
I thought you were telling me to hurry up.
No, it's not the hook. So in the minute that we have left, tell me a little bit. So these are both advanced solutions. Tell me a little bit about how these are becoming frozen in time, which is the danger of these kinds of things as they become kind of time capsules. In what way have you made them future-proof?
Yeah, so at Hauser, one of the things that we really focus on for our product development is making it future-proof for both the current and the future generation of users. So I guess the major thing that we do for people that are looking for this, for simplifying online measurements and for mag meters and for our analytical measurements, is we're making both digital protocols out of our transmitter in addition to analog signals. So you're able to both kind of transition into the IoT world more easily than you would for using only traditional analog signals.
Gotcha. Well, that's great. Thank you so much, Robert. Thanks for sharing this with us. I hope you have a great day. And now I'll pass us back to Dave Spencer.
Thanks, guys.
Thanks, Robert. And to those watching, I apologize if you guys had a brief outage on the sound there. As has happened many times today, we've had several equipment failures, but luckily we have some redundancies in place to deal with those somewhat efficiently. Next up, we're going to be moving in to join Pat Cook. And I'm just going to bring Pat on the line here. Pat, do we have you available?
Everybody who's been tuning in for the past hour and a half, we're at the halfway mark. We're just waiting for to queue up to the next slide. And again, hopefully everyone's had a chance to go down to the description and be able to...
Pat, are you available?
Who have already been talking to us. And next up, we're going to have Pat Cook, not Blair Sully. And Pat Cook is going to talk to us. Or are we? Stand by for a moment. I think we may have lost our next presenter, so we're just kind of scrambling here for a moment.
Hey, Chris, have you got me on the line there?
I'm here.
All right, Pat.
Great.
Pat, did you want to go into your presentation here?
Unmute. I'm just trying to unmute Pat. There we go. Great. So what we're going to do now is
unmuted.
Pass you off to Pat Cook. And he's going to talk to us about distributed architecture. How are you doing today, Pat?
Well, I was just deciding that maybe people should take a vote. And I would think it would probably be reasonably unanimous that I should be muted again. hopefully not. Chris, today I will be hopefully talking about distributive architecture and the new master supported application capability in VTScada. I have about 9.5 minutes for this, and I think that that's something like trying to do the evolution of the species in a 30-second Super Bowl commercial. So hopefully we can get this done reasonably quickly. What I'm going to do is to start off with some very basic things in terms of VTScada, because it ultimately will impact on additional elements. So if we can go to this first slide. VTScada is a single install. So you download from our FTP site the most recent version of VTScada that your key will allow you to install, and you install it. And effectively you install all the features. And on the left-hand side, you can see some of the elements which are part of this basic installation process. There are a couple of things such as the alarm notification and the mobility clients or the thin clients, which are elements that have to be enabled, but nonetheless they are in the basic product. And during the installation process, you enter a key, and the key determines the functionality associated with that particular install. So that could, amongst other things, be whether you have a development runtime license or just a runtime license, and whether you have maybe 2.5 million tags or whether you have 200 tags. The installation process essentially is almost universal, other than there are some minor changes depending upon the particular elements that you're installing. But long story short, once you have installed the application, you have all the ability to run those services on that particular computer. So one single install, put it on that computer, and now I have the conventional single PC, which is my Scada server. If we move beyond that simple one single PC, most people have two workstations, one which is considered to be your primary, and the other one which is considered to be your hot backup. And in terms of VTScada, the hot backup can be very simply a runtime license. So I have hopefully a development runtime license on one computer, and I have a runtime license on the other. One is my primary server, and the other one is considered to be my hot backup. But typically with VTScada, we take it a step further. So on the left-hand side, you can see that there are a number of services. So these are the standard services in a VTScada application. And what I can do is I can take those services and I can apportion them to my two workstations or my multiple workstations. So I can say, for example, alarm notification, I want to be on computer number 1 as the primary server. Configuration, I actually want to be on computer number 2. I'm not sure what a dummy driver is. That was probably something that was designed specifically for me. I may decide, for example, that the Slippy Map service should be on computer number 1. So, Chris, you're going a little bit faster than I am. So the idea is now that I can take these various services and I can portion them over to different PCs. This gives me essentially distributed redundancy. I have two PCs. Each one is doing part of the application, but they are keeping each other updated in real time through constant synchronization. One computer goes down, the other one takes over. But rather than sitting in this world of one being responsible for everything and somebody is the backup, I effectively have both PCs contributing to the application running. Now, this also gives you the ability then to load share within a single application. And the load sharing can either be done manually by assigning different services, as I've spoken about, or can be done automatically. So VTScada does do things like, for example, allowing it to make the decision on who the next thin client session should be. Should it be with the computer that you've gone to, or if somebody else is sitting there idle, maybe VTScada will pass it over there. Sorry, we can get to the next one now, Chris. That'd be great.
No problem.
So what happens with each one of these services is they can be assigned to a particular server list. So in this particular example on the left-hand side, my default server for everything that's not designated to be the responsibility of somebody else is going to be done by SCADA server number 1. And what's going to happen is SCADA server number 1 is going to pass all information on to server 2, to server 3, and quite honestly to my laptop. So you'll note, though, that I have created 3 other services, specifically Headworks, LS1, and LS2. So what happens now is that all the services that are not assigned as separate services with their own separate server lists are done by the default server. But any one of the other services can be assigned to have its own server list. Again, I emphasize that the server lists allow you to have an unlimited number of redundant servers, and also that the failover scheme for each one of these redundant servers can be unique. So if we can get to the next slide, we'll see a little bit more information. So one of the implementations of this in the broader scope of things is this concept of tag area filtering. So what I have is I have a single application, but what I have is I have also identified a variety of individual services within this application. So going from my graphic on the left, the Headworks is the driver that talks to the Headworks hardware. LS1 is the driver that talks to the Lift Station 1, and LS2 is the driver that talks to LS2 hardware. In each one of these instances, the individual location has its own server. In other words, Headworks workstation, LS1 workstation, and LS2 workstation. So these workstations are now, sorry?
1 minute. 1 minute left.
Oh, sure. So these workstations are now the servers for those particular parts of the application. And so with the tag area filtering, I can load tags and say, I only want a 1,000 tag license on the Headworks. I only want a 200 tag license at LS1. I only want a 200 tags at LS2. So I can now apportion each one of these computers in the system to only be licensed for computer tags that I need for that particular location. If we can go to the next screen, please, Chris. One of the newer capabilities is this concept of master subordinate application. So effectively, I can Oh, it's missing. Anyway, okay, I'm sorry.
I didn't like it.
Perfect. And yes, I am not Blair Sully, although he and I share the same hairdo. Well,
Yeah.
maybe not.
Okay, Pat. Well, thank you so much for joining us. And now I'm going to transfer back to Dave. Over to you.
All right, thanks very much, Pat. We're going to go to Mike Stark here in just a second. So I'm going to transfer things over to Mike. Mike's going to tell us a little bit of a lighter side. He's going to give us a story of some of his funnier experiences in the SCADA industry. Over to you, Mike.
There we go. You're clear now, Mike.
There we go. Okay. Thanks, Dave. Hey, it's great to be here. And yeah, producer Peter Diffley asked me, since I'm the new kid on the block here at VTScada, and I'm out of Dayton, Ohio, which has a long history of innovation and all kinds of different things like that, to just kind of do a quick story about innovation and that type of stuff. So what I wanted to talk about was a guy by the name of Charles Kettering, who was the research and development manager of General Motors. And so this is back in the 1920s. And the problem that they were talking about at that time, Charles Kettering was actually talking with the president of Cadillac, a guy by the name of Henry Leland, about painting cars. At that time, they were able to get the cars painted in about an hour, but it was taking like 2 to 3 weeks for them to dry. And so Henry and Charles were talking and said, you know, we got to be able to get this thing speeded up. And Henry says, well, maybe we could do it in about a week or so. And he says, no, we got to be able to get this done in an hour. So a year passes, and Leland drives down from Detroit to meet with Charles Kettering. They have a meeting the whole day. And at the end of the meeting, they're walking out of this the building, and Charles is walking with Henry, and they're looking for the cars. And Henry gets this really weird look in his face, and Charles says, well, what's wrong, Henry? He says, well, I don't know. I can't find my car. I says, you know, my Cadillac was red, but that one's blue. So what Charles had done was he had Leland's car taken and painted and then brought back in that period of time. And kind of the whole point of that was that persistence and innovation can solve any problem. So thanks for having me. That's a real short, quick thing. And I think this automation village is great.
Thanks. They came in right on time. Thanks a lot for that.
All right.
So now, back to you, Dave.
Thanks, guys. Next up, I think we're going to be speaking to Pete Diffley on his vision regarding the automation village. So Pete is the brain behind this operation. He's also the producer who's been in our ears as we've been going through this. So Pete, let me just bring you on the line here and we'll transfer over to you.
So Dave, Chris, I'm not sure, can you hear me, guys?
Oh yeah, I can hear you fine.
Excellent. Okay, well now I know that our team behind the scenes understand the whole idea of juggling plates. You know those people that put up the plate up in the rod and they kind of spin them. Well, that's kind of what's been going on with all of us here, in the small dispersed team of Trihedral that are trying to do this for your pleasure. So I'm going to try and do the impossible. I'm going to try and be my own producer and also time myself. So if I get it wrong, well, hey, we tried. But so yeah, well, I mean, like the concept of the automation village, a virtual trade show, really, it obviously stemmed from the crisis that we're all going through, and we see that from the number of companies that contacted us when we kind of just launched the idea as a very simple concept. Literally only it was less than 2 weeks ago. It was about a week and a half ago. So to go from that to a great viewership and the wonderful exhibitors, as we're calling them, the virtual exhibitors that have been on, and some more to come as well. It's been an amazing journey. So if you're to say, well, where do we go from here? Our intention is that we, in about 2 weeks' time, will actually have what will be kind of like breakout sessions, I guess. So in true trade show fashion, we'll actually have a whole series of topics that will be longer, because you just about get enough to whet your appetite when it comes to the presenters that we've had today. So really, that's a big part of what we're going to try and do, is to create that whole trade show concept and try to keep it going. But we'll have longer topics where it could be maybe 1 hour presentations and white papers and stuff like that. So that's about 2 weeks out. And with your support, and I'm saying all of you who are viewing this and listening around the world, including my parents in Ireland and a few different people, but I've seen people who've registered as far away as Australia. So hello to you and thank you for joining. But we'd certainly like to try and do this again It'll be probably in about 4 weeks' time. We'll regroup to do that. And I think it's a real case of, well, being able to use distributed technology. I mean, the internet thankfully allows us to do this. It can also be our enemy at times, but it's a wonderful asset to do that. And we'd love, with your support, to continue doing this and try and expand it and make it work during this crisis. So I mean, that's kind of it really between so Dave and Chris. Maybe, I don't know if you had any points you wanted to say.
No, I just wanted to say thanks for moving this along. From conception to this moment has been a very few number of days, and I just wanted to say well done, Pete. I know that you've not slept a number of nights in a row, so and also just to remind everyone what an interesting experience it is to be talking to someone with an earbud in one ear and listening to our producer Pete Diffley calmly take me down to the second on the other. Has been quite a learning curve. So thanks, Pete, for being such a good producer.
You've been great, guys.
Yeah,
absolutely.
Thanks very much, Pete.
So I think we have our next prize.
Yes, I'm just going to switch there just through the source. And here we are.
So again, if you missed the first prize giveaway earlier on, you are going to open up your email. You're going to put in Natasha Lutz's email address. And in the subject line, you're going to write I heart VTScada and send that along. And we are going to draw a winner for a $100 online shopping voucher for a popular online shopping institution. So do that now.
Right. And Chris, where will the winners be posted?
That they will be. It's a good question. When will the winners be posted? It will all be online within 48 hours. We will email the winners within 48 hours. This is a good example of talking while I'm listening. So we're going to post it to our website. We're going to email the winners within 48 hours.
Perfect. Thanks very much. All right. I'm going to grab control. All right. Moving right along. Next up is a presentation that is an idea that I thought was great. It's taking some new technologies and actually using them in a new way. So we've seen drones used before to replace the jobs of things like helicopters, but in this case we're seeing drones used in a bit different way. And so I'm going to bring in here Devin Carroll, who's the Vice President of Custom Controls Unlimited. And Devin, just give me 1 second here to bring you into the line. And here we come. Devin, are you on the line there?
Devin, maybe could you unmute your mic? Great, there we go.
Yes, sorry.
Perfect, thanks, Devin. Yeah, we got you.
Welcome.
Right, great.
Tuning in today. How's your week been going?
It's been going well. The coronavirus has kind of given a whole new meaning to bringing family close together for us. But overall, it's been great to kind of regain our kids' focus. I think it's been that's been one blessing that we've got to experience.
Now, have you adopted any new practices that you think you'll carry forward as when you were adapting to this new work environment?
Yeah, well, we've always had quite a bit of remote support, and with our secure connections back into our facility, we're able to do remote support from people's homes. So we're helping remotely where we can and on site where we have to. It's kind of hard in our water and wastewater and power and food system business just to kind of turn it off. So we're doing the best we can with that environment.
Very good. Well done. Okay, so why don't we kick things off here? Why don't you tell us about what we're going to talk about today?
So we're going to talk about one of the problems that we faced in our core business, where we do a lot of remote wireless RF based systems, and no matter how nice and expensive gold-plated type SCADA system we build, if it's got poor communications, it's practically useless. So, and we've had a few bad experiences where cost would get away from us because we were not quite prepared on the front end to know how tall our poles needed to be, for example. And I'm sure any SCADA systems integrator out there that has run into that before. So our computer models are often missing the mark for us. It's a good start, but not getting us there. So we ultimately adopted a policy and said part of our quoting and part of our scope of services when RF is involved is always going to be doing a physical path study. And this unfortunately created a roadblock just from a cost perspective to getting some projects up and going. So that's what we're. Right. So there's traditional approaches and challenge that you can go through to do a physical path study. It involves a lot of equipment, boom trucks, portable towers. It's very, very labor intensive. You have to have a lot of manpower. There's also safety concerns that are often dealing with climbing and such. So we had to kind of come up with a more cost-effective, safer way of doing these physical path studies. That's where
the drones come in.
Yep, exactly right. So, yeah. So and just we still start with computer models often, and you'll see these two. These are one's called a heat map, and it kind of shows how the received signal strength indicators change as you get away from the towers, and then on the right-hand side there is. We pick 2 points, get a cross section in the earth, and we hope to make that red line up without any obstruction. It's there. Yep.
That's right. It's just,
that's okay.
So basically, you're using the drones to map out single strength to do what would be dangerous or inconvenient for a person to do.
Correct, and we still there's still the human element in it. Here's just an example of portable tower, something that is a cost that we hope to avoid in using these drones, but it's also often a piece of the project where that's set up at a certain location, and so it becomes a combination thereof. But ultimately, the goal is to get to a site, deploy the drone. You're up and down in 15 minutes and you're on to the next site.
That's great.
So
we're about halfway through. We're actually going to show some of these videos. You've embedded some videos in this presentation, but I think we're going to show them at the end. But tell us a little bit more about how this works with using the drones.
Okay, so we have a licensed operator and have a lot of rules to follow as far as being able to fly a drone commercially. But we essentially get there, we set the drone up, we have a radio and we have a 4G cell modem on the drone as part of the payload, and then we suspend below the drone the antenna that matches whatever frequency on the licensed or private radio network. And then we're able to, we essentially raise that drone up to different elevation checkpoints, and we're getting feed down to our tablet from both the drone as well as our hosted SCADA system that we use to take the cell data, the 4G data goes back into our hosted system and is collecting all of this GPS coordinates, the elevations, the RSSI values, and it's recording it and mapping it to that location. And that's, we turn to the bearing that we need to, and that's how we do it. So this is part of the study will often involve putting temporary radios on top of towers. So this one is a little black box there. It's got a radio in it, battery powered, that'll sit there through the duration of us going around to all these sites to deploy this drone and get our data. Yep. So then this is a view of a view that's optimized for the tablet that would have all these values on it. And those of you VTS users know that that exclamation point there is our manual data. It's what happens when you wait too late to put your slide together. I had to cheat a little bit. But so this stores all the notes and the heights and the signal strengths and gives us a live view while we're doing the test. and then saves all this data to ultimately generate the report we need.
That's great. So tell us a little bit about the hosted solution that you created. What were some of the, what's important when setting up a hosted solution?
Well, we have a hosted SCADA solution for our clients that has a secure private cellular network that tunnels back into our primary and redundant location sites. In this case, we used, and I'm unfortunately no longer the programmer here, but we used SNMP over UDP, and we connected to the all these acronyms for everyone, the GE's MIB to get all of that information out of that radio. And if you need some more acronyms, I can throw them out there.
How about WOW?
Yeah, that's excellent. I love that one. Yeah, so
I see you've also got the embedded mapping there too. So that's a nice thing. I guess that's an important thing if you're mapping drone.
It is. I mean, and ultimately we can, without the drone even, we can send our devices out sometimes and mail them to the customer and say, press this button. And it's, and we know where it's at, we know what the values are, and we don't have to deploy people to do it. So a lot of values even outside of the drone to using this method of path study.
Now that's really interesting. I think that sort of brings us down to the wire. So what advice would you give to somebody who was looking to adopt this technology? If, again, who's looking for this?
Well, originally it was systems integrators. It was us. We wanted to know this information before we got into the job and realized we made a mistake on the path analysis. But now we've determined that it's really valuable to consulting firms that want to know how to pre-engineer and pre-design what all of these heights have to be. And they realize the computer models themselves are not enough. So the physical study, they can hire us or someone like us to come out and do this physical path study.
Okay, that's great. Well, once again, thanks for joining us. If people would like to learn more about this company and about this technology, again, go down to the links in the description for this live stream. So again, thanks for joining us and have a great day.
Yep, thank you.
All right, and now we'll pass you back over to Dave.
Okay, so thanks very much to Devin Carroll for that. And next up, we're leading into a conversation with Micah Howes and Chris Rowland, both from Wunderlich Malloch. And they're going to be talking about an innovative approach to customized SCADA solutions. So I'm just going to bring them in a moment here. If you give me a minute while I prep the slides. And
no problem.
Just watch my console crash for the third or fourth time today. So just give me 1 second here. I'll just have to bring up those slides again. Okay. So
okay. Hi, Micah. Hi, Chris. How are you doing today?
Good afternoon, Chris.
All right. You guys should be live
really
on the program
happy to be
there.
Here.
Carry on.
Thanks for having us. Again, my name is Micah Howes, and I'm a senior engineer and PE here at Wunderlich Malloch. And I have with me Chris Rowland, and he's a senior controls engineer. And
good afternoon, everyone.
Hi, Chris.
We work very closely together. We do a lot of solutions in the power industry with SCADA and automation. And I'd like to talk to you today about configurable load shed and event reporting. Let's go to the next slide, please.
Sorry, it's just taking me a moment to update. There we go.
So what is electrical load shed? I think everybody probably knows that here in the US, we run a 60 hertz AC system. And so electrical motors and other loads have got to stay close to that 60 hertz to operate effectively. So an electrical load shed system's job is to keep the load on the system balanced with what the power production that's available in that system. Let's move to the next slide. So in this example, we've got a plant here with multiple generators, and it's designed to normally have a connection to the power grid. Now let's say we have a utility breaker trip. If we're already running at maximum output on our generators, we're gonna have to do something. We're gonna have to remove some electrical load. Could be a chiller or a water pump. So we've got to take action very quickly. Let's move to the next slide. And I'm going to let Chris Rowland speak about this. So in our plant, I'd like to describe the fact that we've got multiple generators that use different prime movers. We've got gas turbines, we've got steam turbines, and we've got to balance the electrical load while also being able to meet the day-to-day operational constraints.
All right, thank you, Micah. So what we have here is a screen that we've developed for our custom load shed system. And what it provides is a very configurable interface for our operators. In the upper left, you'll see triggers. And what we mean by trigger are different events that would be loss of generation, such as the generators or the utility source. So for this particular system, it's selected to a loss of utility. And what the screen is showing is based on the loads that are enabled, it's selecting and showing you in real time what's going to actually be shed based on what the system is calculating needs to be shed to maintain a stable system. In addition to being able to enable and disable the loads, you can set the priorities for which loads get shed first. So if you take a look at the lower right corner, you'll see where everything's being calculated, such as what's available for your high priority loads, medium and low, and so forth. If you want to go on to the next slide, we'll show you what happens when an event happens. So here's our load shed reports, and just this little screen quickly shows that trigger one happened, the utility loss. It shows what was available and what was actually shed. The next screen will show the actual report. And one thing that our customers have told us that, they do have different load shed systems in place, and it often takes them a long time to figure out what happened, even if a load shed properly took place and they maintained their plant. So this report shows what was currently running in the plant as far as generators and utility coming into it. Down below, it shows what was selected to be load shed, that total load of 3,477. And on the next screen, it shows what was actually shed. So that's just an indication of the actual relays that were fired and tripped those loads. Now, one thing I want to talk about, the way we maintain this, you can imagine that you need to shed very quickly. So in the background in our control system, we're constantly calculating what needs to be shed, and we're sending, to get a little technical, a bit stream of zeros and ones of the outputs that need to be fired all the time. So when we actually see that trigger, like the utility breaker opens, those zeros and ones immediately get moved over to fire those relays, and the shed event happens.
That's great. 5 minutes left.
Right. You want to move on to the next screen?
So look at that. I mean, with the system that Chris described, we've kept all the load running as much as we could, okay? So you might have lost a single pump, but the rest of the plant is 100% stable. And, the operator can watch the plant and change those priorities on a day-to-day or seasonal basis. And they can see from that report that the system worked exactly as intended. And that gives them a quality document so they can verify the performance. So this is excellent for systems where you need 24/7 uptime of your electrical system. So, all right, we had that event. What happened to our utility cable coming into the plant? Let's look at the next slide. Yeah. So we have a system where we're going to gather oscillography records. And what that is, that's the records of how the relays saw the fault and triggered. And that's on a time synchronized system with an Ethernet backbone. Nowadays, we can do time synchronization over TCP/IP, which is great. And we're gonna grab those records from the relays, and we're gonna sort them by the timestamp and put them in a central location. So if we can look at the next slide. So you can see here, this is like a display that gives you the timeline of what happened. So you can see that red line over on the left, that could be our incoming feeder relay. So we see that event happening. And then the other lines a little later represent possibly our load shed trip of maybe our chiller or water pump. And you can zoom out and look at the overall operations on the electrical system. We can look at the next slide. So with that quick interface, which is just a very easy drill down, we can pull up the actual alternating current waveforms of that incoming feeder that tripped out. Well, look at that. We've got a high magnitude current there on phase A, and it looks like a single phase fault on our feeder coming into the plant. So you can imagine that's a very quick process. Your plant is kept running, you lost a load, and now you've identified that you can see that there was a phase fault on that feeder. Let's go to the next slide. So what we've talked about, as you can see, we've got a configurable load shed system. That's going to get your electrical system staying on. 100% uptime is the goal. And you can optimize that based on your plant operation, seasonal or daily, and operating priorities. And so we've minimized electrical outages to the maximum extent possible. And we've got operation reports that are going to allow you to quantify and verify that your system is operated exactly as intended. And then after you've done that, you can drill right down into the electrical oscillography reports from the protection relays. And they're all there right at your Scada terminal. They're time-stamped, and they're quickly accessible for troubleshooting and correcting the problem. So it's really the ultimate system for a high uptime type of microgrid or industrial or utility electrical system.
That's great. So for a new customer who's come to you and said, yes, I want you to, I would like this technology, what's the timeline in terms of from that moment to having this up and running?
Well, Wunderlich Malech really specializes in customized systems, okay? So what we're gonna do is work with our customer to determine the requirements. And we're going to go through a process of, in detail, drilling down to, how many loads, how flexible does it really need to be? Are there only 2 seasonal modes? Are there, more than that? And how far down into the electrical system do we need to go? So that timeline is really going to depend a lot on our customers' individual needs.
Is there a typical time, or is it just too varied?
Chris, what do you think? That's
Well,
a tall order to throw out a time like that, but
Sure.
I'm not giving you only 20 seconds.
If it's a fairly simple system, we could deploy it within probably a month.
That's great. Well, thank you both, Chris, Micah. I appreciate your time today, and I hope you have a great week.
Thank you.
Thanks.
Now, back over to you, Dave.
Thanks, guys. That was really interesting. It was cool today to be able to see some high-powered devices and the kinds of problems that they have, and then you have low-power devices which are, equally complex in their own right, which are having very different problems. So next up, we're going to join a very familiar face for us from some of the trade shows. And forgive me, Don, as I'm going to have to read your title from my notes here directly. It's very long. So Don Dickinson is coming in from Phoenix Contact, where Don is the Senior Business Development Sector for water. And Don also plays the role of Director of ISA Water and Wastewater Division. So sorry, Don, for butchering that slightly. Let me just pull you in here and allow you to make up for for what I've done. Go ahead, Don. Do we have you there?
I'm here. Hopefully you can hear me.
Absolutely.
Oh, great. Thanks so much. Yes, so my title is Senior Business Development Manager for the Water and Wastewater Sector.
Great. So tell us a little bit about what you're going to talk about today.
Well, one of the things that's really driving the conversation in our industry is America's Water Infrastructure Act of 2018, which we refer to as OWIA. This act requires drinking water utilities to do some things that they've not been required to do before, or certainly not as systematically as they're having to do now. So the Act requires that drinking water utilities serving more than 3,300 customers conduct and certify a risk and resilience assessment. And then within 6 months after that, they have to complete and certify or revise an emergency response plan. And unlike other vulnerability studies that have been done in the past, these are now requirements that must be reviewed and updated every 5 years. Now, the deadlines for compliance for each of the utilities is a function of the utility size, and the largest utilities, those serving more than 100,000 customers, that risk and resilience assessment is due next week, March the 31st. So that deadline's coming up. It's a whole new ball game for everyone, so there's a whole lot of questions there. The key point I wanted to make is that resilience is now the key operating word for the industry, at least for the drinking water utilities. I am going to assume that all the best practices and things that are being done to meet those requirements will be certainly adopted in the wastewater side of things if they haven't been already. And one of the things that we'd like to really talk about with Phoenix Contact is that we've got just a wide range of products that comes into that conversation, especially when you are preparing your emergency response plan. That could be products for networking or for security, for instance. It could be automation and control, lots of communications options there, including wireless. But there's a wide range of products that also can come into the conversation, and I wanted to focus on some of those today, just briefly. One of the ways that we segment our products at Phoenix Contact, because we have so many, is we put them into these areas of functional design. So it makes it easy for us to know what group of products we want to be focused on. And today I want to just touch on the whole idea of power reliability. And this is a pretty big issue for us going forward. And if you go to this next slide, maybe bring that into conversation. And in fact, in our previous presentation, we saw that the many things that we can do to ensure, or certainly to maximize the uptime of our electrical systems. This is a big issue as exemplified by the EPA's initiative over power resilience for both water and wastewater utilities. Now, the EPA initiative really is focused on having backup generators, powers to keep the pumps running. So things around power reliability are pretty important from the big picture view of things. However, what we at Phoenix Contact really focus on is reliable power for these critical control systems, especially the ones that deal with generating revenue or dealing with public health and safety, or in most cases that involves both of those. And so by maximizing the uptime for these critical control and communication systems, we can really have a big impact on the overall level of resilience for a water utility. And you see here, there's some of the pillars there we call of reliable power, and that is how do you go through protection, conversion, monitoring, and distribution. So I just wanted to highlight maybe just a few products in each of those categories, just to give you an idea of what we're talking about. So surge protection, overload protection, these are challenges for any electrical system. What we find, though, is that for critical systems today, especially because there are so many microprocessors in all types of devices, they are particularly susceptible to voltage transients. And that's where our surge protection comes into play. Most people think about the issues around lighting, and of course lighting is the most dramatic form of a voltage transient. However, there are just transients in every aspect of your control system, and what we have found is that if you protect things that are the foundation of your system, such as your power supplies, we know that those things last a very long time. And in fact, when you combine our surge protection for your power supply, we give you a limited lifetime warranty for all the products that we produce downstream from that. So that's a pretty powerful statement to say that we have that kind of confidence in being able to protect our components and ensure, again, maximum uptime for these critical systems. So we may not be talking about keeping the pumps running in this case. What we're talking about is keeping these critical communication systems going, because we know that especially in emergency response, disaster recovery, the most critical system that you're going to have is a communication system. You're trying to maintain lines of communication, maintain the flow of critical data, and that could be for situational awareness. It could be for, again, passing data up to an historian that will be used for that data to show regulatory agencies that things were kept in compliance, or if they went out of compliance, how were things addressed and when was that brought back into compliance. So surge protection and overcurrent protection, the most basic things you can have it in any control system, that's the starting point for power reliability. But it really takes a big step up when we move over to the conversion side of things, and that's things like redundant power supplies, UPS, battery systems. How do you monitor that energy that's being consumed? So just in summary there, just a range of products that under the category of power reliability are very, very relevant today in this conversation about resilience.
Okay, so we've got about 2 minutes left, Don. Thanks for all of that. So unfortunately, well, fortunately, we have you here today in our virtual trade show booth. But normally you'd be having this conversation inside of your very real and very nice trade show booth. I've been to it many times. What do you find when you actually have an opportunity to show people these things? What do you find is the thing that really has the biggest impact?
I think it's the realization of just how fundamental the conversation about power reliability is.
Right.
And I'll give you a parallel example here. Obviously, cybersecurity, which is a big part of the risk and resilience assessments that these utilities are doing as part of AWEA. So for the first time, fortunately, we have some real direction as to what's necessary and required for cybersecurity. But I find that when I start talking about cybersecurity, especially when you get into the nuts and bolts of it, there are so many people who they realize, look, I'm not into the weeds on cybersecurity, and we have some geeky guys to take care of that kind of stuff. So the biggest challenge I have when I talk about cybersecurity is people assume that's over my head, someone else is taking care of that. But when I point out to them that cybersecurity is just one facet of risk management, it's just one aspect of how do you protect critical infrastructure? How do you ensure the availability and reliability of critical systems? I think that power reliability, I get the idea that, yes, you know what? This is fundamental.
That's great. So tell us a little bit about, we just have 1 minute left. Tell us about what's coming up next with your work with the ISA.
Right. And so I am serving as the director for the water and wastewater industry. Applies in addressing the many issues that we have in our industry. And so with ISA, and of course, they have many great standards, including their 62443 standard on cybersecurity. I still consider that to be the best standard for OT security. And so great way to drive the conversation about automation and technology, specifically within the water and wastewater industry.
Excellent. Thanks, Don. Thank you very much. You did a great job. And now we'll throw it back to Dave.
Thanks very much, guys. All right, that was really interesting. Next up, we're going to have Barry Baker. So this is VTScada's vice. Sorry, I'm just getting a note in my ear here. We've got Barry Baker coming up. Barry Baker is the vice president of VTScada. And Barry's going to talk to us a little bit about some of his thoughts. Let's just bring Barry on. And let Barry start by introducing himself here. All right, Barry, do we have you on the line there?
Hi, Dave. Yep. Hi, Dave, and everyone listening. I guess while my title is not as long as Don's, I'll try to be concise for all the attendees who have shared this unique experience today. So my presentation, I'm going to talk a bit more in detail some of the topics we've covered earlier. So next slide, or first slide. So my topic is going to be on maintaining productivity. And what do I mean by this topic? Well, we all have jobs to do, and generally SCADA systems are required to maintain processes and operations in our life. VTScada itself is used in many critical industries, in use in over 1,200 water wastewater utilities in North America, monitoring air traffic control and equipment, controlling large portions of the North American power grid, and major oil facilities worldwide, and some neat applications you saw earlier as well. So it's critical to be run. Historically, our world has been concerned with software viruses, but things have now changed. So I'll briefly cover some of the features within VTScada that can be utilized in case physical access to your application becomes difficult. This can occur if there's a restriction on system integrators who can access your facilities, or if staff are asked to distance themselves and not share operator stations or even rooms. In both of these cases, there's a need to maintain productivity, as processes need oversight, especially when operating in new circumstances that we're finding ourselves today. And the work that system integrators is doing, as you've heard them talk earlier, is valuable. So I'll discuss two key features that can help, and with some tips for the experienced users who may be familiar with them already. Thanks for bringing the next slide up there, David. So remote access. Chris, can you go back to the previous slide?
Yeah.
Thank you. All right. If operators don't wish to share keyboards or control rooms, VTScada can be configured to provide each user with their own session to run on their own computer. Any VTScada license installed on a PC can be utilized to provide thin client access. By this, I refer to thick clients, which are installed on a Wintel architecture. That's what a thick client definition is. This means that a runtime or development license can perform this function, which is enabled by the license key, and it's not a separate installation. Configuration is quite simple, as seen in the dialog box on the left, which is really in keeping with our out-of-the-box philosophy on ease of use. Right? Multiple servers can be added for redundancy purposes, as you see, and configured to load balance, a little checkbox down there. Right? The client computers do not need to be Windows devices, and thus users can operate with their own personal devices, such as tablets. This means if you do not want to share the consoles, they can use their own tablets, which they're obviously used to touching, or their own computers, and you do not have to buy additional devices. This is in contrast to other access methods such as remote desktop or log me and rescue, which you may be thinking of using. While VTScada can be accessed with remote desktop, only one user can access it at a time, and this access must be a shared access if installed as what I call as a console application, like a regular software installation. If you start multiple remote desktops, you run into a problem because each session will end up starting another instance of VTScada, which you don't want. You only want one of your SCADA systems running. If you install VTScada as a Windows service, well, then there's no console desktop, so the access can be via the thin client. Right? With VTScada version 12, your thin client can develop and configure if run on a Windows computer and connected to a development license. So that's something we added in VTScada version 12. On the dialog, you can see that you can designate multiple servers and set them in order that the clients can follow. You can set up access to use SSL, which you'll need to get a certificate for. This will depend on how users access your network, which should be behind a firewall for isolation. Excuse me. VTScada can also be configured for a DMZ setup as well, which is the computer sitting between two firewalls. If you wish, you can configure this server to not share any Windows security configuration of the protected network. No Windows clients set up at all. And you simply set up to use the local accounts of VTScada. And you have no restrictions placed on what the server may actually do. And yet, you can have restrictions on what the server can actually do. So you can limit its ability to do writes or control, or where it can access screens. You can actually also, in VTScada, limit what tags it can run. So you can pare this server down if you want to run it in a DMZ access point. Next slide, Chris. Some remote access tips. So realms are a neat feature in VTScada and serve some useful purposes. If you're adding many remote users, you might want to restrict users to only see certain areas of the application. In advanced configurations, this can be used to support multi-tenant applications, which are commonly done for cloud-hosted installations where multiple customers operate on the same system. This is akin to an apartment building, where every tenant has their own privacy and security, but share the same building and resources for economic reasons. So that's more advanced in VTScada, but it's simpler uses as well. You can also be used to perform a user-defined load balance scheme or access. How this is done is any application can appear in multiple realms. So you might have VTScada set up with one realm today, and then you expand a bunch of users. Well, you can give those users, put those users in separate realms and give them a separate URL access. You can also change their server lists, so in alternate forms or varying groups. So you could configure operators to access I/O servers and managers to access servers that may be configured as the historian. So you're sort of deciding how you want your access managed by your server list in separate realms. You don't have to buy additional licenses. This is just managing your access to what you currently have. In addition, you can also configure the maximum number of clients per realm. This means you can reserve some of your thin client licenses to certain groups, so they can always have a private and reserved access. So that would be some, you see there, the max clients. I can set that down. So I can set aside maybe operators to be always have 4 accounts, knowing I have maximum 4 operators, and give the balance of my thin client licenses, which are simultaneous access, to other users. Next slide, please, Chris. Right. Remote access tip on the Internet Client Monitor. So as you add more of these users, you can use the Internet Client Monitor to manage them and maintain oversight. This is available on every thick client license. It was originally developed to manage cloud-hosted systems, and then we made it available to everyone. Right? It allows you to send messages, diagnose connection issues, or see link quality. Right? While the operator logins and system access are recorded in the alarm system event log, as Pat Cook talked about, this application records the amount of time accessed by thin clients and what pages they're actually looking at in real time. So it gives you a real-time dashboard of who's on the system. Next slide.
Great, about 2 minutes.
Yes. VTScada's version control is included without charging every license. While runtime-only licenses cannot author application changes, they can apply change set files. Now, Blair covered this earlier in greater detail, so I'm not going to repeat all the features he covered. As Glenn and Blair noted, though, a key feature of VTScada's integrated version control is the change set file. This is the core of the distributed version control system, which allows multiple users to configure the same application simultaneously without being connected to it or any central server. That's key. That allows you to send your application out to your SI, who can make a change while you continue to run your plant, run your process, and send it back, and you can review and apply it, just as Blair demoed. To do this, since the change set file has an encryption key on it, which is a military SHA level grade security, you need to set the SI up in your security system. Now, if you have a problem that your IT department won't allow the outside users to be configured, and you won't allow them to come on site, you have another way of operating. You can actually set the user up as a VTScada security access only, and then let him make his changes. So he still doesn't have access on your network, but he can at least continue to build and make changes for you in your application. And last slide, Chris.
1 minute.
Yeah. So some points of note. These are all fully described in our help system. There's online tutorials showing how to set these up for configuration. Or, just like always, you can call us. You can reach out to our tech support group. There's online chats. There's also availability on our website to come in and engage our sales group, who are mostly engineers, as you heard from Alan Hudson, the bright guy from Alabama, and assist you in the configuration of your system or showing you some features. We're here to help. And I think that's all I have to say right now.
Well, that's great. Thanks, Barry, for sharing all of that. So that just leaves me just enough time to thank you for joining us, and good luck with the rest of your week. Thank you, Barry, for you and Glenn and the whole company doing such a great job of helping us all be productive during this time. This has been great.
Yeah, thanks,
and on
Barry.
that note, I will pass us back to Dave.
So right now we're going to just jump to the next slide quickly, which hopefully will be another prize draw.
Woo! All right, everybody, by now, hopefully you know the drill. We've had lots of response to the last couple of draws. So this time we're going to pick 2 winners. So open up your email, type in natasha.lutz@trihedral.com, and then in the description line, type in different by design. And you have to get it right because humans aren't actually sorting that list. So it's got to match exactly. And we're going to pick 2 winners, each of which will get a $100 online shopping voucher. And if you need to know, the contest rules are posted by clicking the link below or also clicking the link in the description of the live stream.
All right, thanks very much. That was a nice presentation from Barry. Barry, if you're still on the line, don't go too far, because next up we'll have Barry and Glenn talking together to help kind of close things out. So everybody's been along for a little bit of a ride today. If you're on this end of the microphone, then things have been very interesting. But you know, this is our first go at it, so we will learn from where we are. So I'm just queuing up now to bring on Barry and Glenn shortly.
Glenn, do you want to unmute your mic?
So,
there we go.
Barry, Glenn, we've got you on the line.
Sorry to step on you there, Dave. This is Glenn. I'm the one on the right. This is our normal office attire, and I wear that around the house too. That's just a picture. I don't know where the guys grabbed that, but it was a nice event that we attended a couple of years ago.
Yeah, Entrepreneur of the Year award event. It was kind of nice. We don't get that every year, but we should every year.
So I guess we want to share any final remarks for our first of hopefully many virtual trade shows.
Yeah, I'd like to thank everybody for joining us. One thing I got from this whole thing is that software is an integral part of every aspect of automation. It's just pervasive in our world. And those involved with it are just making modern life possible, making the world better. So thank you for all our partners involved with this. I think it helped make this a success. Thanks for everyone joining us. Thank you for your time. I know time isn't free, and I hope you did get something out of this. Event. So Barry?
Yes, this event was kind of unique because obviously with the travel restrictions and isolation requirements to defeat this virus, we thought, well, people do have important work to do. They go to trade shows not for the dancing girls and martinis as the traveling salesman is set out to be, but more they go there to solve their problems, to learn about new technologies, to advance their the processes for the efficiency or productivity. So they're important. So we came up with an idea of how to share knowledge in an open format for the betterment of those attending. I think for some of us presenting as well. As Alan mentioned, we're becoming more efficient at ways that we casually used before. We've been fortunate as we're sort of part of the digital economy that our software is distributed, and we've been unfortunate that we've got hit by hurricanes and stuff in the past so we can work remotely. But it's all about collaboration and working together. So we hope this event helped with that, and we hope the following events will further that. And again, we want people to come to us with problems they look to solve. That's the important part, how we help each other out.
So I'd ask that if you'd like to follow us on social media, LinkedIn and Facebook, we'd appreciate that. Comments on how you found it, how there would be improvements to be made in this sort of venue, those are also appreciated. Certainly I'd invite you all, if there's anybody left watching, to send in our technical questions directly to the exhibitors, those making presentations, so that they can engage you and answer your questions more directly, rather than just listening to the stream. And lastly, I'd like to point out that we do have VTScada Lite. It's our free version, fully functional version of VTScada, and it's free for commercial use for the first 10 uses. So feel free to download the 50IO version of VTScada. It's available on our website. You don't have to fill in any forms. Just take it and use it. It's our part in making the world better. Thank you very much, everyone.
And just one closing thing on that. We are a one product company, but we'll also make it the VTScada Lite will expand its features for any of those of you who are involved in medical processes in the fight against COVID-19. Just contact us for details. That information's on our website.
Right. Anyways, to be on that, this is something we're doing. That if you have something that requires more than the VTScada Lite, a fully functioning, bigger version for the battle against this disease, we're happy to provide it free of no charge, and perhaps even contribute some of the engineering time towards making it happen. So just let us know.
All right. Thanks very much.
Great. Well, thank you. Thanks to you both. And thank you, Dave. You brought us in with a really great keynote speech. Do you have any words for us on the way out?
I just wanted to thank everybody who took the time to join us today and realize that, we are both sort of doing this at the first go. There's a lot of equipment and a lot of separation between us. So we've been, as Pete said, spinning many plates. Certainly it's not flawless, but, we'll learn. And the next one, I hope, will be smoother, cleaner, and just better than this in terms of the implementation. So I thought we had some fantastic presenters today, and I hope that the people watching got as much out of it as we got making it. Chris?
And I hope that the things that went wrong were at least entertaining to watch.
That's right. Yeah, like he says, if nothing else, they saw the synchronized high diving while blindfolded act today. So thanks very much to everybody.
So, as Glenn pointed out, I'm not sure if you're aware of this, but on YouTube, you can actually leave comments for things. So, and lots of people do. So I invite you to do that. Please let us know in the comments below what you thought worked really well, what you thought we could do better, and what we could do to recreate a trade show experience,
right,
short of offering beer around 3 o'clock in the afternoon.
Yeah, and we put out very few promotional videos. It's mostly educational videos that we show on our YouTube channel. So we would really appreciate it, anybody who's watching, if they could subscribe, because once we the limits that YouTube puts on us for what we can and can't do during these sessions is partially based on the number of subscribers that we have. So it would really help us out.
All right, let's wrap it up. So most of all, I want to thank my partner, Dave Spencer. You did a great job today. Dave was by far doing the most technical things all at the same time. So it was fun. Thanks, Dave.
I've got very familiar with where the reset buttons are on all of the bits and pieces here. So, and big thanks to Pete for putting this on and really pushing this through. As Chris noted earlier, a lot of late nights. And Pete's driving the thing and keeping the momentum and making this turn into a real event. All right. Thanks very much, guys. Goodbye.
Thanks, guys. Take care, everyone. Bye-bye.
Bye.
Bye, everyone.